requires substantial
No.
development to build a
It'd be
vehicle
on top of
capable
the
of
second
such a
stage
mission.
LSS.
So it will ultimately take driving control of the
Aqueducts.
International Space Station, so to speak, and propel the entire station into a precise deorbit trajectory that terminates in an unpopulated ocean area, so that any elements that could survive atmospheric reentry pose no risk to the public. So to achieve this, the deorbit vehicle will need 6 times the usable propellant and 3 to 4 times the power generation and storage of today's Dragon spacecraft, just for scale. It needs enough fuel on board, not just to complete the primary mission, but also to operate on orbit in partnership with the space station for about 18 months. Then at the right time, it'll perform a complex series of actions, and Dana describes some of those burns and steps over several days to deorbit the International Space Station. So first, the deorbit vehicle will perform orbit-shaping burns to put the station in a low elliptical orbit, and then eventually it will perform a final reentry burn to lower the perigee to intersect with Earth at the intended location. So the thing that I think is most complex and challenging is that this burn must be powerful enough to fly the entire space station, all the while resisting the torques and forces caused by increasing atmospheric drag on the space station to ensure that it ultimately terminates in the intended location. So the vehicle design will build upon SpaceX's operational Dragon cargo spacecraft with an enhanced trunk section that will host propellant tanks, engines, avionics, power generation, and thermal hardware tailored to complete this mission. So almost a spacecraft in and of itself attached there as a new trunk. So one of the benefits of leveraging Dragon's rich flight history is that we can continue to use NASA-certified hardware for a number of the key systems, like the docking system and propulsion system components like our Draco engines that were developed for our Dragon crew and cargo missions to the International Space Station, and that we have a long history of flying together with NASA. So while the assembly level design is uniquely developed for this mission, we intentionally use building blocks of components that NASA is familiar with and that SpaceX has extensive experience building and operating. So like all new vehicles that SpaceX develops, the new deorbit vehicle will leverage the agile, innovative, and test-heavy concurrent engineering approach that SpaceX utilizes throughout development and leading up to flight. So no differences there. And just maybe a final word. You all know SpaceX's goal is to make life multiplanetary, and supporting space station operations has been an important step towards this goal, and safely deorbiting it as we collectively support the future of commercial space stations is the next step. So we're honored to have been selected for this contract, and we're proud to be a part of the continued evolution that makes humanity a spacefaring civilization.
All right, thank you to our briefers for those initial remarks. We will now open it up for questions. Again, if you are on the phone bridge, press *1 to submit a question. Once your name is called, please do state your name, affiliation, and to whom you'd like to direct your question. And if at all possible, please try to keep it to just one question so we can get to everyone.
Just one question.
If you find that your question
Sure.
has already been answered, please press *2 to withdraw it. And our first question will be from Bill Harwood with CBS News.
Hi, thanks for doing this.
Hey, thank you very much. I want to make sure, can you hear me?
Hey, Bill, we got you loud and clear.
Okay, hey, thanks very much. Well, I guess this is for Dana or Sarah. The picture you guys have put out of the vehicle, the DV vehicle attached to the forward of ISS shows quite a few engines at the back thrusting. Can you give us a sense of the number of Dracos on this vehicle? Do they all fire at one time? Or do you use them in separate bunches? And what's the max DV capable of this vehicle? What kind of thrust can this thing provide? Thanks.
Sure. So I think your first question was about the engines. There are 46 Draco engines total. 16 are on the capsule already for attitude control. I think 30 for the Delta V maneuvers in the trunk. And your second question, could you repeat it?
Yeah, I was just wondering, of that total number of engines in the trunk section, do they fire at once in major burns, or are you just firing, clusters of those guys depending on what you need? And I was just trying to get a sense of the total Delta V the vehicle can provide. I know you said it's 4 times the thrust of a normal Dragon, but I don't know what that is. So if you could help me out there, I'd appreciate it. Thanks.
Sure. Yeah. So quite a few of those aft-facing Dracos are firing at the same time for that final deorbit burn. Somewhere between 22 and 26 of them will be firing at a given time to deliver about 10,000 newtons of thrust. And then the total Delta V that the vehicle has to provide was provided in the requirements for the contract. I believe it was 57 meters per second. So.
Thank you. Next up, we have Gina Sensuri with ABC News.
Bowersox. Ken, you spent many, many months up on the space station. This must be a little bittersweet for you, and was there any thought given to how you might preserve some of the history up there, or will it all just end up in the ocean?
Well, thanks. Yeah, my time on ISS was wonderful, and I'd love to go back. I'm glad it's going to be flying for a while longer, so we can all watch it and think about some of the things that you brought up. Right, it's not too late for us to bring some pieces home. Unfortunately, we can't bring home really, really big stuff, but I'm sure there's some mementos that we'll get back and that will end up in museums someday. We'd like to be able to bring big pieces home, but the station really wasn't designed to be taken apart. It was designed to be put together, and it would be relatively expensive to try and bring something really large home. But I would love, the emotional part of me would love to try and save some of ISS. But the practical part of me realizes that using something like the USDV and bringing it safely back into the ocean somewhere is the most practical approach.
Thanks, Ken. Our next question comes from Marcia Dunn with the Associated Press.
Is it for sure the Pacific that you would be aiming for, or might it be the Indian? And in 2030, is that when you would abandon the station and start to really lower its orbit, or do you really want to see it down in 2030, barring an extension for some other reason? Thanks.
The South Pacific Ocean is one of the potential locations. Since we don't have to decide that now, we're still leaving that open, but that certainly there is a very large footprint there that we could use, but there are other locations that we're still looking at, so we'll decide that at some point in the future. In terms of the overall timeline and timing, there's some interesting variables that we don't control. One of them is solar cycle, and so we can control the launch of the USDV, the actual time that it takes to then drift down from where we fly right now to those final altitudes that I was talking about for the burn. That's a variable that's got a little bit of flexibility that we can't completely control. So our approach is we'll use some average estimates for environments, and we will kind of back up from the time of reentry. Right now, the normal plan or end of life at the end of 2030 means we'd splash in the ocean in January of 2031, and so based on the environment, we'd back up from that to pick the launch date. We expect low solar activity then, so it's probably about a year and a half before that we'd want to launch and dock the USDV. And of course, the environments and the behavior of the solar cycle is something that we would watch and adjust dates as we got closer.
Our next question comes from Will Robinson-Smith with Spaceflight Now.
Much for taking the time to speak with us today. I guess going back to Gina's question, this one for Ken Bowersox, once the ISS is put down in the ocean, I know obviously it would be far away from land, so this may be an expensive proposition, but has NASA thought about making an expedition to salvage whatever pieces may come back in larger chunks that could potentially make their way to a museum? Thanks.
That's a pretty good idea. I think there's going to be very little left based on our analysis when it hits the ocean, but it would probably be a good idea to go out there and take a look and just make sure when the time comes.
Thank you. Our next question comes from Elizabeth Howell with Space.com.
Thanks for taking the time, everybody. Might be for Dana. It's an International Space Station scheduling question. So you had mentioned Crew 9, and as we all know, the FAA is considering a request to be launching Falcon 9 again under a public safety determination while the mishap investigation is still going. So anyway, I realize it's all FAA side, but I just wanted to ask from a procedural standpoint, would NASA go ahead with that? Just say, yep, the FAA is good and we're going to be launching Crew 9? Or do you have your own process to be determining when and if to be launching Crew 9? Thanks.
That has nothing to do with this
Yeah,
conversation.
that's a good question. We have our own process that's outside of what the FAA does. Of course, the FAA has got to finish their work and authorize SpaceX for launch.
I hate
separately,
people that do this.
we take a close look. There are a couple configuration differences in the rocket between our configuration and other commercial flights. So we look at things like that. And of course, SpaceX is very transparent with their investigations. Not only is the FAA tied in and following along, but NASA is also included in following along. So we take an independent look at it as we determine our readiness for our launches. Sarah, do you want to add anything?
Yeah, you mentioned it there at the end. I was just going to mention that you guys have been in lockstep with us participating in the formal investigation process. I think I'm grateful that we have this framework to work through when you experience events like this, not just to figure out the specific cause of the issue that was observed, but the right actions to prevent it going forward, but also how it might be related to any other system, what separation there is between the configuration that was flying on that mission versus, as you mentioned, the configuration.
I'm sorry, guys. I don't mean to talk over the presser so much, but I'll be 100% honest with you. They asked about the FAA determination on the basic request to bring Falcon 9 back to operations because it's grounded right now. It's called public safety determination. They asked, basically what's going on there? Is NASA working with the public safety determination? So one, that's an idiotic freaking question because of course they are. Duh. Usually the agencies work hand in hand. Two, public safety determination hasn't been made and NASA isn't going to tell you anything that the FAA hasn't already told you. So NASA basically said the FAA and SpaceX basically said maybe less than a week ago that we're working on that determination, and that question was basically, hey, how's that determination going?
Burn. So the burn
look, they're still talking about it.
The engine continued to perform the burn through the leak, but the result of that leak and that long coast period that followed resulted in the second burn not being able to be performed successfully. So because the second burn wasn't completed, the engine kind of stepped through what it's programmed to do in these scenarios. So it deployed the satellites and then it passivated itself. But since the second burn didn't finish, they were deployed into a pretty low orbit. So we expect the orbit to decay relatively quickly from atmospheric drag. If it hasn't already, I think most of them might have already completed. So that's what happened last week. We know how to step through the stages of this process, and it's a joint investigation board, as I mentioned, between our government customers and the FAA and SpaceX chief engineers. So more to come there. If there's any impact to near-term launch dates, we'll let you know. But right now, we're just trying to wrap up that investigation, and then we'll know if there's impacts.
The investigation's ongoing. They don't have any findings yet.
Thank you. Our next question is from Joey Roulette with Reuters.
Thanks. For Sarah, I just wanted to quickly follow up on those comments you made. You said you guys are making really good progress on the Falcon 9 investigation. Do you know what might have caused the lock leak, or what's your latest understanding into the fault tree and what all happened there? And then for Dana, real quick, can you quantify how much of the ISS will be surviving reentry and splashing down, making its way to the ocean? Like how many pounds or what percentage of the overall structure? Thanks.
Yeah, so I think those are the details that I know right now. I know there's probably much more detail that when the investigation process concludes that we'll have and be able to share. This is our top company priority right now. And then as the Dragon team, my team, we just continue to progress through our nominal launch preparations for a number of upcoming launches on our manifest. So including Polaris Dawn, Crew 9, CRS-31, and we're kind of standing ready for word that we're cleared to fly those missions. And Dana, if you want to talk about your part.
Yeah. Let's see, in terms of
What pisses me off about this is that it's lazy. It's freaking lazy. They just, oh, there's a press conference coming up. I can talk to SpaceX face to face. No, or you could send them an email regarding this. Now we have a press conference that has nothing to do with the point of said press conference. That's lazy. Pisses me off. I hate this.
Minimize, as a spacecraft breaks up, you minimize how far those parts can be distributed.
You want to get a ruling on it, send them a freaking email.
I think the first key thing is it'll be a tight and small footprint. That's the goal. In terms of the size of the pieces, I don't have it in total mass. I can tell you ranges of size of pieces. Some things will completely burn up, like the solar rays are expected to completely burn up. Other very dense structures or structures that are kind of buried under structures can survive. I would say in the larger spectrum of what could survive, our assessments show that we could have things like the size of household microwave ovens, a number of pieces that are that size, and all the way up to the size of like a small sedan, like a car sedan type size. So there's kind of a range of numbers of pieces, and we have estimates in terms of how many of those types of pieces we think we'd have. But there are a lot of variables in play, including the orientation and the angle of the spacecraft as it's tumbling in and as it comes in. But again, all of the pieces that do make it through will be clustered together in a very tight footprint as they go into the ocean.
Thank you. Our next question is from Kenneth Chang with the New York Times.
Ken,
hi, thank you. This is for Dana. The Axiom module is supposed to be detached and then used for Axiom stations. I was wondering how that fits in with this timeline.
Yeah. That's a good question.
So,
thank you, Ken.
I think, as you know, right now on board, we actually have a docking port on the forward part of ISS. Before Axiom launches, our plan is to swap a docking and berthing port to put a berthing port at the forward. And so the actual activity to do that doesn't take that long. There's a couple of spacewalks and some cabling that we have to reconfigure, both inside and outside. And so our plan would be, at the end, when Axiom departs, we'll go back into a reverse configuration and flip back to the docking berthing configuration that we're in today. So
on an
probably
Axiom
takes
module, most
an
likely
execution time. It takes a few weeks to get that done.
Our next question is from Jeff Faust with Space News.
Didn't Ken Bowersox just say at the beginning of this that the ISS isn't really able to be reconfigured? Just saying. And then they just talked about reconfiguring it. That's weird.
And question for Dana. When do you anticipate procuring the launch of the USDV? And given its size, is this something that could launch on a Falcon 9 class vehicle, or do you anticipate requiring a larger vehicle to launch it?
Because
Thanks.
Jeff asks good questions, always.
Yeah, it's because of the amount of propellant it's carrying, and just as kind of a data point, I know Sarah talked about the 57 meters per second, but that's on the order of it's actually over 16,000 kilograms of just propellant. So you're up over 35,000 pounds of propellant.
Whoa.
So in total, that spacecraft pushes us over just the normal smaller class rocket. So we've got to be on a heavier class rocket. In terms of timing, generally speaking, it takes at least 3 years before you fly. You got to really start your procurement for the rocket. We may do it a bit earlier for that, just to kind of have it ready and have it kind of on hold. But we wouldn't pull the trigger to actually go integrate the spacecraft and the rocket together until we're committed and ready to launch.
They can, Yannick, but they don't.
Thank you. Our next question is from Micah Maidenberg with the Wall Street Journal.
Hey, thanks so much.
2 good questions in a row. Let's make it 3.
And Dana, NASA evaluated a couple proposals. Were you surprised you just have a pair to look at, or was that expected or unsurprising given, SpaceX and Northrop's familiarity with the station? And then Sarah, would you expect SpaceX to be competing for that future launch procurement? Thanks.
What?
Ken, do you want to start with that one?
Yeah, I'll take it. I was really happy that we got proposals from the companies that we did. The companies that sent us proposals are both great companies, and it was awesome to see that interest.
In it, dude.
I would have expected a few more, honestly, but I was very happy to get the ones that we got.
And I'll just add that, we did place an emphasis on flight heritage hardware, meaning flight-proven hardware. So, whether it's on the spacecraft that's flying today or some other spacecraft, the challenge, I think, to industry was trying to maximize the use of flight-proven hardware. So it doesn't completely surprise me that our current transportation providers who are already flying and compatible with things like docking to ISS.
Separate proposal, Phil? For what? For launch vehicle procurement?
Closely aligned to what we're looking for. With Ken, though, I thought we might get a couple others, but definitely no surprise with the two we got when we look at what our request was to industry.
And just quickly, your question for me, yes, if the opportunity arises for SpaceX to launch the USDV, we'd happily support. We've got a couple different configurations across the Falcon product line, and believe we could support this mission. So we'll look out for NASA decision-making in the future on that.
They always only do
Great. Our next question is from Stephen Clark with Ars Technica.
So we had 3 good questions.
Hi, thanks for taking my question.
Steve,
I have a couple for Sarah. I think Dana mentioned earlier the total propellant mass on the USDV. Do you have a total overall, total wet mass of the entire vehicle at launch? Just how massive is this entire vehicle? And then also, Sarah, in the last few months, we've seen some reports of some debris from Dragon trucks making it to the ground unexpectedly. Curious what SpaceX is doing to mitigate that. Thanks.
Sure. I don't have the exact number in total mass, but I think it's pretty close to the number she was quoting. It's upwards of 30,000 kilograms for the vehicle. Dan, you're looking at me like you might know more.
Well, the prop alone is 16,000 kilograms, so you might be right that the total vehicle might be closer to the 30,000 kilograms.
Yeah. Okay. And then I think your second question was about trunk demise. So, yeah. So maybe backing up a little bit, just to round out that topic as a whole. So the majority of space objects utilize a relatively passive approach to disposal when their mission's complete, right? Drag causes the orbit of all space objects to get lower and lower over time into thicker and thicker layers of the atmosphere until eventually they're flying so fast with so much resistance that they break apart. And if they're small or have the right quantities of the right materials, they'll entirely burn up. So there's a complex model used by the entire industry to evaluate the size and shape and material quantities and confirm that the space object is expected to entirely demise during this atmospheric reentry process. So if this is the case, there's no need to design a propulsive deorbit system, for example, to land it in a specific location, like Dana was explaining some of the larger vehicles do, because it's expected to disintegrate before it gets there. This happens all the time for thousands of space objects. So there is known variability and uncertainty with this modeling approach, and I think the industry is constantly feeding back improvements to make those predictions more accurate. So as you're referencing, everyone's aware, there have been a few pieces of Dragon's trunk which were expected to fully demise, but that have made it to the ground. And so I just want to say we take this very seriously, and we've been partnering very closely with NASA and with the FAA for some time now on what our options are, what alternative solutions are available to us to ensure public safety on every mission. So more to come there. And then just to clearly separate from the topic of today's briefing, right? Because ISS is so big, NASA has always known that it will not fully demise, and they would need an alternative means of ensuring public safety, hence the plan to propulsively put it on a trajectory that terminates in an unpopulated location in the middle of the ocean. So, yeah, hopefully that answers your question.
Thanks. Next is Jonathan O'Callaghan with Aerospace America.
Great, thanks very much. Sarah, can I check why is SpaceX using Dragon for this USDV instead of a Starship vehicle? And Ken, can you just clarify how set is NASA on deorbiting the ISS? Is it 100% set, or is there a 2% chance the decision could be changed and it could be pushed into a higher orbit per chance? And a quick one for Dana, are the Progress vehicles now a redundancy, or is that plan scrapped entirely? Thank you.
Good question.
Yeah, so to answer the first question, we looked at the requirements for this contract and what NASA needed for this deorbit vehicle to do, and this was the best solution that we found to work within those requirements. There's a range of thrust that it needed. Starship has too much thrust for meeting those requirements.
There's no such thing.
We wanted to propose the vehicle that would best meet the needs that the mission that they asked for.
Let's see, in terms of the Progress vehicle itself, the Roscosmos segment, so all the propulsion that's on board, both in the service module and then also what's available in the Progress cargo vehicle, still play a critical role. They will continue to be primary for normal vehicle attitude control, for debris avoidance, if we encounter debris on the way down. And then also, depending upon the fuel we have left at the end of life of ISS, they may help us a little bit with altitude lowering. And then in the very end, we're looking at if the U.S. deorbit vehicle encounters a contingency, though not ideal, with just 2 progresses, but that's what's normally available on the Roscosmos segment. We're looking at contingency options for a severe down mode in the event of multiple failures on the USDV to use what we have left on the Roscosmos segment. So still a factor, but not part of the primary plans for the critical burns at the end of life.
And then on the question on the end of orbit, end of life plans, I've never seen anything that's 100% in space, right? What usually happens is we constantly iterate and constantly revisit decisions that we've made in the past. So it wouldn't be surprising at all to me if in a couple years folks came in and took a look again at the work that's been done to try and decide what we would do at ISS end of life. That's pretty common with all our programs. And I honestly think they'll end up in the same spot. They might adjust the timing a little bit. Having a deorbit vehicle will give them flexibility and a little more certainty that they've got something that they can use when the time comes, whether they go a little bit earlier or a little bit later. But we've looked at lots of different options. The program has looked at lots of different options, and especially the raising option is one where you have to have all the data to really understand it. I asked about that when I first came back to NASA a few years ago, and the thing that surprised me is the orbital debris environment makes raising it problematic. We could actually make the orbital debris environment a lot worse because of impacts up at that higher altitude, increasing the amount of debris at that upper altitude, then having that debris come down eventually to a lower altitude. So again, the responsible thing we believe right now is to go ahead and bring ISS home all in one piece.
Thanks, Ken, Dana, and Sarah for answering that one. Our next question is from Issam Ahmed with AFP.
Hi, thank you. For Sarah, just based on the picture that we see that you guys put up, it does appear that the DV will be larger than your regular Dragon. Is that definitely the case, and do you have a sense of how much larger? And will it be entirely autonomously piloted, or will there be a room for sort of people to come in and make adjustments, obviously before the final maneuver? And so also a very quick one for Dana. What's the resupply supply situation like right now on the ISS in terms of do the astronauts have enough of everything they need, given the sort of uncertainty right now about when the next Cygnus supply could come? Thank you.
We're up to 3 questions per person.
Hey, so it is quite a bit bigger. I believe the trunk alone is about twice as tall as the standard Dragon 2 trunk. So you are observing correctly, and I suspect that the steering or the software, the control will follow the philosophy of all the vehicles that are flying today, which is some combination of functions that the vehicle performs on board and some combination that the controllers down in mission control perform.
I'd say in terms of resupply to ISS, we're actually in good shape right now with overall consumables, things like crew supplies, food, water. We do have
I just wanted to point out that man just asked, do the astronauts have enough food? I'm just pointing it out. No reason.
Not too long from now, and so
you know what? We're
that's
just skipping
kind of the
that part.
general plan for contingencies. And so the general threshold programmatically is you can usually deal with up to about a 4-month slip. At that point, you kind of start running your reserves all the way down. So that's just kind of a good yardstick or way to think about it. But I am tracking a couple of critical components that I'd like to get on board pretty soon.
And so what are those components?
For life support system for urine processing, if you recall, when we flew up Starliner, we delivered some components in that area to help with our urine processor, and I've got some more of that hardware on the Northrop Grumman flight that will help us get back into a normal kind of healthy configuration with our urine processor.
Thank you.
Thank you. Our next question is from Ryan Catan with NSF.
Ryan!
Hi, thanks. The image that you released shows what looks like, at least to my eyes, it just looks like a normal cargo Dragon with that new extra large trunk on the end. Will this be a previously flown cargo Dragon just with this new trunk, or are you going to be constructing a brand new normal Dragon vehicle with this new trunk on? Thank you.
Question, Ryan, my boy.
Sure. Yes. So the capsule portion will be a Dragon vehicle that we pull from our fleet, a cargo Dragon, and then, as you mentioned, the entire trunk section that is designed to perform this mission, which is different than all the missions we've performed so far, is entirely new design. So on the Dragon vehicles we fly today, the trunk serves a few purposes. It's kind of like a service section. So it has solar arrays that generate power for the vehicle. It has a radiator that radiates heat. Sometimes we take external payloads that are going to go on the outside of the space station inside that kind of empty shell of the trunk. So this trunk needs to perform a large amount of different objectives, and so that will be a new design.
Next up is Megan Bartels with Scientific American.
Hey, can you hear me okay?
Yes, we can.
Awesome, thank you. Megan Bartels with Scientific American. Super quick follow-up for Dana from Joey's question. What is the radius or diameter of that debris footprint you mentioned being super tight? And then a real question for Sarah. Does SpaceX expect to use the deorbit configuration for other projects? Or if this is likely to be a one-off flight configuration, can you talk a little bit about the value in doing all this engineering, especially within a company that so prioritizes reusability? Thanks so much.
That second part, that would have been my question.
Actually, the footprint for controlled re-entry that we target is 2,000 kilometers long. It's really narrow. I can't remember off the top of my head. They're really, as you can imagine, you're kind of accelerating forward very quickly, as you're re-entering. And so really the debris tends to kind of lay out in a very narrow, kind of long path. And so our footprint will limit that path to 2,000 kilometers or slightly less.
Great. Thank you.
And to your question, yes, this vehicle will be one-off, but it does provide a lot of value to it. Well, I will say it is one-off, but it builds upon technologies and hardware that we're currently flying, and I think that those benefit each other. Us continuing to operate the Dragon fleet will give us more and more data to inform as we're developing this new vehicle and what improvements we might want to roll in as we go along, and then vice versa, the development of this new vehicle will surely help us discover things that we may want to roll back into the operational fleet. And so, yes, the vehicle is one-off, but I think that there's a lot of back and forth between our current operational fleet. And for me personally, I think more of the value of doing this is it's a wonderful full circle experience, I think, for me and for SpaceX with partnering with ISS all of these years to go from being the first commercial vehicle to approach and attach to the space station all the way through when they're ready to pass the baton to the next platforms that will come after. And so, I can't express enough how honored we are to be a part of that step.
Thank you. Our next question comes from Marina Koren with The Atlantic.
Hi, question for Ken and Dana. Are you planning to recover anything from inside the ISS before deorbiting, such as equipment or mementos? And if so, do you envision contracting SpaceX to do Dragon return missions specifically aimed at bringing those items home, basically acting as movers to empty out the station? Thanks.
I'll start and then Dana can jump in with more details, but there's some little things up on ISS that I think we'll probably want to bring home. On the last cargo Dragon that comes down, I can't see us affording any dedicated missions right now. But for example, the ship's bell, ship's logs, maybe some panels that have patches on them, some display items. There may be some technical hardware that needs to come down and would be useful for research purposes or technological development purposes. But Dana, you probably have thought through it a lot more.
No, I mean, I think Ken's exactly right. We don't really have the disposable income for dedicated missions for bringing hardware home. What we will see as we get closer to the end of life, the number of spares. Today I return a lot of hardware, refurbish it, because that's very cost effective, and then refly it as a spare. And so at the end of station's life, of course, you don't have a specific driver to return it for the purposes of refurbishing it, so it opens up more flexibility with what we choose to bring home. If there were, there will be a lot of things I think that people are interested in, whether it's from a memento standpoint. There could be some things that are useful to researchers, for example, who want to get more things home or things that play forward to a future platform. So it's really work in front of us to decide, and we have plenty of time to do that, what we want to bring home. What we're really looking at is, as our resupply flights towards the end are more focused on just kind of the final deliveries, the return manifest needs really, really change, as you don't need to bring home spares to refurbish them anymore. So that's going to free up some space for us.
And in terms of bringing people home, is there a specific time you have in mind for when the last crew member leaves and when you would start that deorbit, whether for safety or planning reasons?
Yes, our current plan has us doing our final crew exchange right before we launch the U.S. deorbit vehicle. So we'll do a crew exchange. We'll get a fresh crew on board. We'll launch the deorbit vehicle. Of course, that will then occupy both of our docking ports. I've got a crewed vehicle on one port, the U.S. deorbit vehicle on the other port. Once we check out the U.S. deorbit vehicle, we'll start drifting down. So the crew will actually drift down with us. We won't go much below 330 kilometers with the crew, because that's about where the crewed vehicles, their certification range is. Our expectation is that we'll hit that point about 6 months before reentry. So the crew will ride down for a while as we're drifting down, and then they'll depart about 6 months before.
Our next question comes from Douglas Gorman with Payload.
Yeah, hi. Can you hear me?
Yes, we can.
Yeah, great. So I just had a question on, I think it was Dana's comment that you were going to be waiting until another commercial space station was up to bring ISS home. If you could just give us any details on that regarding either how that affects the timeline if another commercial vehicle can't get up there, or what kind of commercial space stations you envision being up there in time to do the passover. Thank you.
I think Ken can help with some of the higher level context. I'll give you just some thoughts specific to the end of ISS. What we will plan to do, obviously as a goal, we'd really like to have some continuity to what we're doing in low Earth orbit for any number of reasons. One of which is we've done a fantastic job building up a transportation capability across the commercial industry. We've built up a great, robust research capability, and of course we've got a lot of international partners. And so the desire is really to make sure you keep continuity and keep those, I'll say, swim lanes in different areas really healthy. And so we'd really like to see these commercial destinations up and flying and functional to some extent so that we have a smooth transition between the two. As we get closer, we'll come up with looking at more specific criteria to align it to decisions that we're making on the ISS side to make sure that we're aligning those well, and I will hand over some of the bigger picture thoughts to Ken.
Yeah, I'll just say that our main goal is to avoid any type of a separation between ISS and the platform that comes next. We'd love to have some overlap, but there's lots of things that could keep us from being able to do that. Resources is one, development schedule for the new vehicles is another. We're going to make sure they're ready before they fly them, and we wouldn't want to hurry them up. And then just how things are going with ISS, that's another possible factor. So we'll be weighing all those things and doing our best to minimize any type of separation between the current platform and the platforms that come next. As Dana mentioned, a big factor in that, it's the research pipeline, the cargo transportation, the crew transportation, trying to make sure that whole system is healthy and ready for the new platforms. So we're thinking a lot about the transition. We're trying to manage it to minimize any type of disruption, and we'll use all the flexibility that we've got to avoid a disruption, but we'll have to react a little bit to how the situation actually develops.
Our next question is from Marcia Smith with spacepolicyonline.com.
Thanks so much. My question is for Ken, and it has to do with the funding for this. Could you tell us what your current estimate is for the deorbit vehicle plus launch, and over what period of time that is? And with the sharp funding constraints going on in Washington right now, what is the outlook for you getting the money that you need in these early years? And specifically, I don't think there was anything in the appropriations for fiscal 24, but were you able to channel some money for fiscal 24 in the operating plan, or how much do you actually have in 24?
So we were able to get a small amount put into the previous year's appropriation, so we have clearance to move ahead with the program. And the next step is to try and get the full funding if we can. The administrator's been quoted that he's trying to get $1.5 billion to fund purchase of the U.S. deorbit vehicle, the launch, and all the other associated costs that could go with the deorbit. The actual cost of the vehicle from itself, from SpaceX, is a lot less. But less than half of that 1.5, or say on the order of half of the 1.5, depending if we need to do any extra items working with SpaceX during the development. And then the launch vehicle, those are typically on the order of a few $100 million. And then the rest is integration costs and other reserves to make sure that we'll be able to do it. We've asked for, in a supplemental, $180 million. That's out there in a supplemental that's awaiting action by Congress. But if we don't get that, this is important enough to us that we'll have to take it out of our current funding, and it could affect ISS operations.
Do you have any indication from the Hill so far if they're going to support your fiscal 25 request?
The Hill is very supportive, and we've gotten tremendous support from the executive branch and from the legislative branch. But as you know, even really critical legislation can take a while to work through the Congress right now. So we're being patient and letting them do their job and expecting that they'll bring it forward here pretty soon.
Our next question is from Jim Siegel with Florida Media Now.
Hi, everybody. Thank you for taking my question. Jim Siegel from Florida Media Now here. I understand that the plan all along had been to eventually deorbit the ISS when the commercial space stations came aboard. But my question is this: suppose some organization came along and said, we would like to use that ISS for another 2 or 3 or 4 years or whatever.
Sell it. That was my
idea.
Be. That's what I would want.
What are the specific issues or limitations that would prevent that kind of thing from happening, if at all? Thank you.
Good question, Jimmy.
let's see, Ken, maybe I'll start with kind of the assessment that we did when we did actually look at the potential for seeing if there was industry interest in kind of managing and flying ISS. We did some work, I don't know, maybe this was 6 years ago, just gauging industry or other entities' interest perhaps in, at the end of ISS life, taking over and managing and operating ISS. And we learned a number of things back and forth with the industry. But one of the complicating factors with ISS is, of course, it is in aggregate a combination of many different suppliers who have helped to build it, many different countries. So there isn't a single focal point where you can just kind of hand over a data set. And though NASA owns some portion of the data, we didn't actually go procure it or put it together in the sense that you would be able to go hand it to someone to go operate it. And so what we learned from that is the supply chain, the number of different entities involved is so complex that it ended up not really being a practical thing to kind of hand off to someone else. If you think about, just as an easy example, on the USOS, the US segment, we've got the really large solar arrays, and so we're providing power for the Japanese, for the robotic arm. So we're kind of the power provider, and also for the Roscosmos segment. But over on the Roscosmos segment, they're providing all the propulsive capability. And so the spacecraft is really built and designed to be integrated across all of these parts and elements and functions, including the robotic arm, which is really critical to maintaining the vehicle. So it's not just as simple as just kind of taking over all the parts, because a lot of different entities still own pieces of it.
Okay, good answer. Thank you.
Yeah, I think I'll just echo Dana there. One of the critical factors is just coordinating with all our partners. It's not just our decision on what we do with ISS if we were to decide to fly longer. And we need to coordinate with all the other branches of government that help provide guidance for us, all of our other stakeholders. Right now, we've got clearance to operate through 2030, and that's as far as we have clearance. We would need to have approval to go beyond that. And, like I said, cooperation of all our partners.
Okay, thank you.
Thanks. Our next question comes from Yuichiro Inakuchi with Kyodo News.
Hi, thank you for taking my question. My question is to Mr. Bowersox. I want to know if the participating countries have already accepted or approved the retirement plan of the ISS, including Russia. Also, are you expecting any contribution from the partner countries like Japan for the safe retirement of the ISS? Thank you.
A good question. Not the worst.
So I can let Dana give you more particulars on specifics, but in general, all the partners share the deorbit responsibility in proportion to the mass of their systems and elements that are at ISS. We've coordinated and continue to coordinate with all of our partners. I think final approval is probably a strong way to describe it, though. We still have more discussions as we finalize the plans, but they're all aware of our work with the U.S. deorbit vehicle and all agree that moving forward with this deorbit vehicle is an appropriate way to proceed. Dana, anything you want to add?
No, I'll just add that, after we announced our selection, we did actually get together with all of the partners. We held what's called the Space Station Control Board, and all of the program managers from the different partner agencies met, and we gave them a good overview. Of course, in the formulation, the concept of operations and the approach was shared, and we were able to recently share a little bit more detail. And so the partnership works with us. And like Ken said, there's a lot of implementation details that we'll work through later, but the partnership is in agreement with the overall plan. And then typically for contributions, they will each technically owe a contribution based on the percent of the mass they have on board. And as I think we've shared before, they like to do that as an in-kind or a barter type exchange for value. And so that's also work in front of us with each of the different partners.
Our next question is from Robert Perlman with Collect Space.
A long press conference.
Thank you. Working off some of the earlier questions about bringing items down, the white paper that NASA put out about this process mentioned that you've engaged the Smithsonian and other organizations, and I wonder if that includes the international partners. Will NASA be taking requests from its partners, including Russia, to bring certain items back down for historical preservation? And Ken, you mentioned that that you don't see reserving downmass capability, more or less using available capability to bring down these items. Do you see the ranking historical preservation over extending science operations to the last minute? So if the Smithsonian, for example, says they wanted a glove box or part of a glove box, or Canada said they wanted part of the Canada arm, that you would disable part of the space station for preservation? Thanks.
So I think our partners will want to have that discussion with us, and I think everybody will have something that's important to them that they'd like to talk about bringing down. The same thing goes with some of the prioritization between science activities or bringing back some of the preservation items. ISS has a really good process to work through some of those questions, and I think as we get closer, we'll have a list, and they'll go through, figure out what's capable, and figure out how to maximize the return to everybody who's interested in whatever is there as we prepare for the end of ISS. And our partners, depending on how things develop there, we could see that there's more than one way potentially to bring items home from ISS. We certainly have the Russian Soyuz as an option. We've got the Dragon as an option now, and our ESA partners have talked about having something that's available to bring items home. So we would all work together to maximize the return for the whole partnership.
I would just add that each partner in our barter arrangements and agreements, each partner on the USOS, so ESA, JAXA, and CSA, they're given allocations for both upmass and then also return capability. And so, each partner can work within their own allocations for what they want to do. And then, like Ken said, if there's something beyond that that they want to discuss, we'll all get together and have a discussion. We don't have prearranged agreements like that with Roscosmos, since they have their own vehicle capabilities, and as Ken mentioned, Soyuz has return capability. That's much less likely. That's not something that's a normal part of the exchange and kind of barter arrangements in the program.
Our next question is from Manuel Malzanati with Exploration Especial.
Thank you. Manuel Mazzanti from Exploración Espacial. I guess a question for Dana or Ken. You mentioned before that there's the idea is to avoid a gap between the deorbiting of ISS and new commercial space station. But I'm assuming this is directly related with the Axiom Space timeline, or if they get delayed for some reason, the potentiality of having an extended life of ISS is getting more real? And if that's the case, how far beyond 2030 can you go? That's my question. Thank you.
It wouldn't just be Axiom. We've got 3 partnerships that we're working on right now. Blue Origin, Starlab LLC, and Axiom, and then all their partners. If we could get any one of those available before ISS is ready to come home, that would make me pretty happy. Again, as far as the date, any extension, we would have to coordinate with all our partners and with all of our stakeholders outside of NASA. So that's not something that we would start at the last minute, right? That would have to start pretty early in order to work in that into the plan. if we get to that point and didn't get an extension and it takes longer to get the new platforms, we would take whatever steps we could to minimize the impact of that gap, right? So I don't think it would be something that is unsurvivable, but it's something that we would like to avoid just to maximize efficiency. Dana, anything you want to add?
No, I think that was a good summary, Ken.
Thank you, Ken. I was asking because of the Axiom is the only one that is going to be using the ISS as a platform. That's why I thought it was strictly related, but thank you.
Yeah, we're
Thank you.
thinking about all the platforms. That's right.
Thanks, Ken. Our next question comes from Anthony Colangelio with Main Engine Cutoff.
Hey, thanks. For Sarah, is there any commonality between this Dragon vehicle, I don't know if it has a name, and Dragon XL? There are some out there doubting the existence of Dragon XL, so it would be cool to hear if there's any commonality and what the status is for that vehicle as well. Thanks.
Good call. Good question.
Good mention of another vehicle that is being developed for a very specific mission. So I would just say each of these Dragon variants or evolutions are designed for the mission that they have to accomplish. Dragon XL needing to go to deep space, needing more radiation protection, power storage, things like that. This vehicle needing a ton of propellant, a ton of engines to provide a lot of thrust to push the ISS. So I think there's commonality in all of our spacecraft, and we learn a lot one from the other and try to apply lessons learned across all of our fleets. But you're right, Dragon XL is a bit unique, like USDV is unique.
Next question is from Leo Enright with Irish TV.
Thanks very much. I'm just curious, was any consideration ever given to using the European Automated Transfer Vehicle? I mean, the original NASA deorbit analysis for 57 meters per second DV was in the ballpark of 9 tons of propellant. Now, I know Dana has cited a much bigger figure, but I'm just wondering, that would be in the ATV ballpark. So was it ever considered?
You know, I don't know if there were really early discussions. Certainly they would have been before my time. I would tell you in the last at least 12 years since I've been in the program and part of the program, the focus has really been heavily on progress. That may be because ATVs weren't flying anymore and that line was no longer open. It also may have been, very early on when we were looking at the Progress vehicles, we were optimistic that it would meet the needs. And of course, ISS did grow over time. There were a lot of changes that changed our understanding about what we would need. So I think that all evolved and we realized the Progress wasn't an ideal option well after ATV had been retired and not flying anymore.
So, no. A simple
Next question is from Jack Kerr with Payload. Jack, if you're speaking, we can't hear you.
Hi, can you hear me?
Yes, now we can.
Yeah, my question was answered with the Dragon XL question, so thank you.
Okay, great. Our next question comes from Ken Kramer with Space Up Close.
Thanks, man. Thanks for not wasting people's time. Appreciate it. I actually mean that.
Ken, we also can't hear you if you're speaking.
Kenny.
Can you hear me now?
Good.
Hello? Yes. Okay. Yeah, my question's for NASA. Thank you. I'd like to know about raising the orbit. I want to go back to that question again. Are you actively looking at any potential extension by raising the orbit at all, or have you totally given up on that idea? Because I ask because these commercial stations with the budget cuts could be delayed. So I'm very concerned about that. The other thing is that NASA, other uses of this USDV. I know SpaceX said something, but What about using this? It seems like a great capability. What about using this for science probes or Mars sample return? You're looking out of the box for other solutions to that. Would you consider that at all? Thank you.
Let me start with the first part about the raising the orbit. And if I understood your question, that was more tied to extending life of ISS versus retiring it. But just to make sure I kind of hit both, I think Ken kind of explained why there are considerable challenges. The energy cost, obviously, for going up is much, much higher than coming down, and what you'd have to do to get to a safe, higher orbit is substantial and with increased risk as the micrometeoroid environment goes up. But in terms of just for extending life, we actually have talked about how do you optimize and where do you fly, and could you fly higher to reduce the demand on propellant delivery. So we have looked at some trades there, and because we fly where we fly, all of our vehicles and our spacecraft and their propellant tanks are all basically sized for kind of where we are. So we've actually looked at both ends, both for disposal and just for kind of optimization of flying, and neither one really made sense. And I think Sarah will take the second part in terms of extensibility of the USDV. I mean, just from my knothole, from a NASA standpoint, when we've talked about it, we certainly recognize that in staying in LEO, this whole discussion about how do you safely dispose of vehicles at the end of the life will kind of persist into needing methods like this. And so I can imagine future fieldies leveraging, whether it's a Dragon baseline or not, but capabilities very similar to this.
Yeah, that's a great idea. We've certainly developed vehicles for specific capabilities that we wanted to go accomplish, and then discovered later new applications. So you're right. Depending on the size of future space stations, they'll end up with the same needs, and so anything's possible.
And our last question for the day is going to be from David Curley with Full Throttle.
It's a variant. I understand it's a custom bespoke kind of vehicle, additional Dracos, additional propellant. Can you detail why a vehicle like this is going to cost the kind of dollars you talked about?
Sure. So I think I've talked about the complexities of the vehicle itself. I think there's also a number of complexities that come with actually pulling off a mission like this. So one example is I mentioned that one of the most complicated parts about the deorbit burn is that it has to be continuing to operate in a different environment than we're used to operating while pushing ISS with all of its appendages, right, that are having increasing drag on them, and those cannot thwart it from its mission of getting it to the target location. And so NASA did a lot of planning on the fault tolerance approach for something like this, and that's something that we have to go think about together. I think you'll see in the request for proposals for this contract that there's also a number of unique, I would say, not contingencies, but there's unique aspects of actually going and doing this that NASA planned in advance for, things like dwell time to have the vehicle ready ahead of need, or as we've been talking about, the exact timing being uncertain of exactly when its operation will happen, storage capability to extend out further. It has operated in space much longer, which is a new capability to be developed that's several times what we do today. NASA is looking at what kind of critical spares strategy they want us to have for any number of contingency scenarios where you would need to have long lead parts in production to provide a contingency vehicle or elements of a contingency vehicle. So all of these things, I think, add up to the articles that you see, but it represents a lot more than what meets the eye.
I think I would just add, maybe I I probably should have put this in my opening remarks, but when space station starts dropping below that 220 kilometer point, we will have a very hard time managing a lot of our systems, and that we don't know exactly when things will fail out. We do know that we will start seeing performance loss in a number of areas. Power is one. Our vehicle will start heating up quite a bit more. We expect to lose communications capability as we're going down. And so one of the really unique things that we had to do with the deorbit vehicle is ask that spacecraft to independently take care of all the capabilities needed in the last 4 days of deorbit. Today, when visiting vehicles come and dock to us, we provide them with power, data, communications. They can go through us to get to, for example, the TDRS satellite network. But because we know that we'll start losing functionality as we get kind of draggier and interacting more with the atmosphere, we had to levy on this vehicle the capability to be completely independent and take care of all of those assets that ISS normally supplies the services for. So that's another unique element with this vehicle.
And thank you to all who did submit questions today, and thank you to Ken, Dana, and Sarah for their time and even going a little extra over to accommodate all the questions we received. You can continue to follow along for more updates on our social media platforms, blog, and online. But for now, that will do it for us here. Thanks so much for joining.
This does conclude today's conference call. We thank you all for participating. You may now disconnect and have a great...
Okay, cool. Bye. I just really want to know the context behind historical missions. The ISS assembly missions, Dean, were insane. 35 assembly missions between 2000 and 2011. Some of the ballsiest missions that NASA has run, to be 100% honest with you. Yeah, there's some... ISS assembly was not easy. It was not easy making a station that big, which, you know, like... I see a lot of people in chat saying it kind of sucks seeing it deorbit. I understand the practical reasons for deorbiting the thing, but I'll be 100% real with you. I've never, ever, ever thought, like, I never, how can I say this right? NASA making excuses really pisses me off. Like, it's so gross. It's such a disgusting look. Like, well, you know, we can't bring some of the modules back down because, you know, we don't have the money, and, you know, the feasibility is just not there. It's not sustainable. The most practical solution would be just to deorbit one piece. We don't really want to do it. Shut up. Like, I hate it. I hate it when they do that. I understand the reasons, you know. And they are valid reasons for not wanting to, I don't know, like bring some of the modules back down, for instance. But goddamn it, is it a terrible look. It's a terrible look. It's just gross. That's not what NASA's about, and I hate hearing them have to say it. It's not their fault element, but yeah, it's certainly not helping the problem either. You know, it's not very practical to do stuff like that. What the hell up? Once again, you know, I understand the reasons. I get it. But it doesn't mean it's not annoying when they say it. Yeah. What is the environmentally responsible way to do this? Disassemble or destroy? Yeah, element, yes, absolutely. Couldn't they just deorbit to the moon? Nah. LeChuck, no. Pushing it out to the moon would require a gigantic freaking rocket. The moon's a long way away. It's 250,000 miles. You need a big vehicle to do that. The ISS is huge. It's 419 tons of space station. And it wasn't really designed to be boosted like that. That would be like trying to make a speedboat out of an oil rig. It's not really supposed to do that. The ISS is basically, think about its mobility the same way you think about like an oil rig. Oil rigs really can't. They have propulsion, and the propulsion is there to keep them centered over like a well if you have a floating oil rig, but it's not really designed to go across the entire ocean by itself. You know what I mean? The ISS is kind of like that. It has its own thrusters, but those thrusters aren't really, they're only really designed to make it to raise and lower its orbit, and that's about it. And if you wanted to go further, it would require a ton of modifications. Now, here's the thing. I'm not saying we can't do it, but I think it would be better. I mean, you got to remember, some of these components on the ISS were engineered and designed and built in the 80s. I think it would be better to bring it down for historical preservation, to show it off as a significant part of NASA's existence. The ISS has been around. It started as Space Station Freedom in the 80s and morphed into the ISS by the early 90s.
Discovery, go at throttle.
And then it started operations in 2000. First launch for components was in 1998, operations into 2000. The ISS program is at this point a significant chunk of NASA's history. And I think that's what the most annoying part is about them saying, we maybe bring back down a couple of patches or something. Like, you know, it's, yeah, I think it speaks volumes to, you know, NASA's outlook on stuff right now. Hey, Vet Gaming, what's going on? Is it possible in KSP? Oh, hell yeah. Oh, yeah, we could do that in KSP. Just have more struts, bro. I mean, the loss of historic stuff is sad, Glass Eye, and I'm not saying you need to bring down the entire ISS. One module. Now, here's the big thing, guys. I think, okay, so with that all being said, I noticed two things about, there were a lot of questions there, and there was a lot of stuff said. That was a lot of information conveyed very, very fast. I noticed two things here. So one, first and foremost, SpaceX's contract is a variable price. The contract stipulation is for up to $843 million for development of the deorbit vehicle, the USDV, the United States Deorbit Vehicle. That's what they're called. I also noticed that the launch procurement is not set in stone, i.e. they haven't bought the launch vehicle for the USDV just yet. They said that the USDV right now is going to be somewhere on the order of 30 to 35 metric tons. It's obviously Dragon-based. Obviously. It's obviously Dragon-based, and if I had to guess, my money would be on a Falcon Heavy launch. Now, the vehicle development is in flux, so it might not end up looking exactly like that. However, the launch procurement hasn't happened yet. Now, once again, the launch procurement is most likely going to be Falcon Heavy. But the way NASA was talking, the way they were saying, no fairing, awesome dude, it's Dragon derived, so the way they were talking, it's very interesting to me. The reason why is because SpaceX said this is very much a one-off design first and foremost. The SpaceX rep said that we're not going to do much with this. This is a one-off deorbit vehicle that's just designed for this purpose. You probably won't see another one unless somebody else needs to deorbit a space station. If they want to pay us, we'll make another one. Makes sense? But NASA also kind of hinted at they don't really know what they want to take down yet. So between those two things that I said before and that, they said maybe we'll take this down, maybe we'll take that. That tells me that they don't know just yet. And that this will not come into like fruition, this design is in flux. The finalized design of the deorbit vehicle is not really, it's not done yet. So they'll have better ideas about what they want to bring back down when the deorbit vehicle is finished. But the most interesting part here is that the vehicle procurement is in a separated contract. Now that does happen. That does happen from time to time. They split the development with the launch services. They split those contracts. That usually depend. I mean, ISS operations historically have not done that, which is interesting to me. So, like, they're usually bundled together. The launch vehicle procurement and resupply vehicle or crewed vehicle usually is all bundled into one. Commercial resupply is a good example. Commercial crew is another good example. You're buying Dragon and Falcon 9. You're buying the vehicle that's going to be up at the ISS for a little while, and you're buying the launch as well, and they rope it all into one contract. Now, interestingly enough, this contract is variable payment, most likely due to the flux in the design, meaning that they might change things over time because this is a one-off design. It might need special requirements that they haven't thought of yet. But here's the thing. Okay. Everything that I just said there is most likely what's going to happen. Most likely going to SpaceX most likely going to develop the deorbit vehicle. It's probably going to launch on a Falcon Heavy or maybe an expended Falcon 9, right? Most likely. And it'll most likely stay up there for about 1.5 years. Basically slowly lowering the ISS's orbit, and then until it's in a decaying orbit where they're absolutely sure where it's going to come down. And then most likely, depending on schedule flux and vehicle design and launch, etc., it'll probably come down sometime in 2030, maybe 2031. It really depends. That's what most likely is going to happen. However, here's the hopium part. Here's the part that I hope for. There's a lot of leeway in the development contract. There's a lot of leeway. There's a lot of leeway in the development contract, and there's also a ton of leeway in the launch services procurement. They don't know exactly when this is going to be finished. They don't know what it's going to launch on. I'm hoping that they choose Starship. You know why? Because NASA, this is the hopium part. This is very unlikely to happen, I will say. But that doesn't mean we can't dream. I'm hoping that this launches on a Starship. Now, does that mean a Starship is going to go up to the ISS? No. But if it does launch on Starship, that means Starship is operational for contracted missions. I think it'll be good to go by 2028. I'm pretty dang sure. And I think personally they did that on purpose. I think personally that was not an accident separating the launch services from the development. Usually they're roped together. These aren't roped together. Especially, they are roped together for ISS operations. So, because of this, I'm going to sit here and hold out that maybe in the future, some of that development contract, which has a variable of income, it's rated at up to $843 million over time. Some of that in the future might be dedicated to launching the deorbit vehicle on a Starship and maybe using the Starship for potential ISS applications, like taking down bigger modules. I'm going to hope. And we'll just leave it at that. Yeah, Hunster. I think, because if you listen to all those questions about exactly what they're going to bring down and how they want to preserve the ISS, there were questions about the Smithsonian, etc., etc. They were very vague. They were very vague about what they want to bring down. Now, that tells me that it's either A, not high on their priorities list, which is just very annoying, which is most likely what's going on, or B, they don't know yet because there could be an ace card in the hole here. Starship, we know from its baseline specifications, will have the ability to be able to dock with things. We know because SpaceX, Elon, whomever, says that, you know, SpaceX has a ton of experience with docking two ships together from ISS operations, and will easily be able to dock two starships together for on-orbit propellant transfer. So we know that Starship is built, it has docking capability built into it. And why is that important? If SpaceX is lifting their experience from the ISS docking to make Starship dock, it's very reasonable to me to think that they would be using some type of heritage system. i.e., Starship in the future will basically have Dragon's docking system and docking software just lifted and put into it. So, if it is utilizing Dragon Heritage hardware for docking, and I don't see why it wouldn't, that's just the smart thing to do, I don't see why we wouldn't be able to see a Starship get there sometime in the future. Once again, it's unlikely. And I'm not trying to give people hope. I'm hoping myself. Could you disassemble it? Yeah, that mumbo jumbo about the ISS not being able to be reconfigured to be taken apart is bullshit. Oh, excuse me. That's stupid. No, absolutely not. The station is a modular design on purpose. They've reconfigured modules many freaking times. Saying, it's not really designed to be taken apart. Maybe that's in reference to the Russian modules, but the Russians invented modular space stations, so highly unlikely. The station has gone through many reconfigurations during its assembly. To sit here and suggest that a CBM-based modular space station, CBM is the name for their station docking ports. These things, you've seen them before. That's a common berthing mechanism. Meaning, so it's an androgynous type of docking port, meaning you can click it together with any module. So, long story short, you could take Kibo and they could grab Kibo with the robotic arm, the Japanese module, and they could attach it down here if they really wanted to. You could do that. It uses a standardized power plug, standardized docking port. It's absolutely reconfigurable. What most likely is going on is that NASA, it's too much work. That's honestly it. It's too much work. The money isn't there for those types of operations. Blah 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 blah. To sit here and say that a space station that's built out of entirely modular components is somehow not modular is hilarious to me. Now, Ken Bowersox, I'm not saying he's wrong. He could have also been referring to the integrated truss segment, that big metal bar, the crossbar that goes across the space station that holds the solar panels and most of the space station's auxiliary systems, batteries, etc., etc. I'm pretty confident that was not designed to be taken apart, but the modules are designed to be reconfigured. And let's be honest, no one's going to give a frick if they bring down a piece of the truss segment. But, like, I honestly don't care if the truss segment comes back or not. I don't care. I really don't. The modules that I would want to bring down are the ones that hold people. That's where the history is. That's where the heritage is. Too much work or too much risk. They basically said it was too much work, it's not practical, it's too much risk, blah, 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 blah. It's not too much risk. You put it there. You already have flight heritage here for how to put the space station together. Like, no, it's just that's what I mean about making excuses. That's gross. They could just say, we don't want to do that. We don't want to do that. We'll make another space station. I'd be fine with that, but cost isn't there. I hate that, dude. I hate it. NASA making excuses is gross. It's disgusting. It's a disgusting look. What risk? Yeah, that's what I mean, Snibbles. You know, what risk? There's going to be... They assembled the space station with a space shuttle attached to it when 14 people were on the space station for a lot of these modules. 7 shuttle crew and 2 Soyuz crews. 7 people on the shuttle crew and 2 3-man Soyuz crews. They had like 12, 13 people on the ISS during some of the most difficult assembly missions. The cupola would be awesome in a museum. Exactly, Pop. That's what I'm saying. Those are the components I would want back. I don't really care if we lose the truss segment. I don't care. I want Kibo, Columbus, Node 2, the Harmony module, Node 1, Destiny, Node 3, cupola module. That's what I think needs to be gotten. You could do all that. You know why? You could do all that. The station actually, now that I'm thinking about it, you could get all that except for Node 1. Actually, Destiny would be... Hold on, I gotta look at a picture of the ISS. I have to remember how this damn thing is put together. Give me a second. I'm trying to find a good picture. Oh, you're not getting the Destiny module back. Nope. Yeah. No, that's not happening. Yeah, the truss segment is tied to it. See? 1, 2, 3. I'm pretty sure that's what Ken Bowersox was talking about. You're not getting that back. No, not a chance. You'd need a space shuttle to do it. But then again, we can sit here and hold on to hope that SpaceX basically has a variant of Starship somewhere in the deep annals of SpaceX R&D. They have a variant of Starship with a shuttle payload bay inside of it. So cut the truss off? Bad idea. Now, see, here's the thing. I'm not saying that that's a bad idea because, I'm making excuses. That's a bad idea because that free floats the truss segment. The Canadarm would not be able to wrangle something that big. It has very, very tight mass constrictions for the servo power amplifiers that are on the space station remote manipulator system. Long story short, Canadarm is strong. It's not strong enough to hold the truss segment in place. So even me being gung-ho about bringing this down, you're not getting Destiny back. You'd have to disassemble the entire truss system. I would only even explore that option if Starship was operational and capable of deorbiting modules right now. That's not enough time. There's not enough time to basically even repeat the operations of disassembling the space station. How long is the ISS? It's about the size of a football field or a soccer field. What, your football or my football? It doesn't matter. They're more or less the same size. Wait, Starship doesn't have a real payload bay? Not that we've seen yet, Willie, but I think it will in the future. Just kick it back to Earth. Well, that's what they plan on doing. The problem is that there's that atmosphere in the way. So, because of... here's the thing. I would even say that that's probably not worth it. I'm not going to say that they couldn't do it. Because, once again, excuses are gross. It's disgusting. I'm not saying that couldn't be done. You could do it, but that's where I would draw the line. You're not bringing Destiny back. The Destiny is the U.S. laboratory module. It's this one that's bolted to the S0 truss segment right here. You could do it, but you'd have to basically disassemble the ISS in the order that it was assembled. It took 11 years to do that. Could we do it faster with Starship? Well, yeah, maybe. That's what I'm hoping for. But let's get Starship operational before we even talk about that. But once again, I'll say it once, I'll say it again. This could be just me hitting the hopium. I say that the chances of this happening are slim and none. But there are leeways in the contracts for the US deorbit vehicle and the vehicle that will launch the US deorbit vehicle, the USDV, are all very open on purpose. I think it's on purpose. They're very open because you never know. I know that they have a variable contract pricing structure for the United States deorbit vehicle. SpaceX does with NASA up to $843 million. So maybe they changed. They said it was for leeway in the development. Maybe they changed the vehicle. It's possible. SpaceX has changed the vehicle in the past. They changed Falcon 9 from 1.0 to 1.1 after being awarded the resupply contract for the ISS. Just putting it out there. I'll be very honest. I think money is wasted on sentimental values. I understand that you all want it in a museum. Jordis, I honestly think bringing at least one module back down would be super useful to see the long-term effects on hardware. See the long-term effects on hardware of something that's been up there for 20 years. That would be what I want. What I would want to see, to be 100% real. Like, you know, and let's just say they can't get at that Destiny module. Let's just say what I'm saying is right. You're not going to get that unbolted from the truss segment. Columbus, Kibo, the Japanese storage module, Japanese exposure facility, Node 2, the pressurized mating adapter, Node 2, Node 3, the cupola, PMA2 over there, so that's PMA2, that's PMA3 right there. PMA2, PMA3, these little adapters, all the open experiment and storage platforms that they have up there, the alpha magnetic spectrometer, that's been up there since 2011, all the ancillary equipment. It could be super useful data for seeing how stuff fares long-term for spaceflight. I'm like, if it was up to me, I think a very good case could be made. The remote manipulator system, the robotic arm. The robotic arm could be super useful to understand, you know, the long-term effects, like being able to take the whole thing apart. You know, you can't do that up in space because you have basically oven mitts on when you're working on something out there, right? The potential scientific gains on some of these pieces of equipment to get some R&D on long-term stay in low Earth orbit is invaluable. I'm not even talking about a sentimental value here, to be honest with you guys. I'd say it would be nice to put the modules in a museum, but only after they've been fully disassembled as much as they possibly can be, so you could learn. Hey, how did this computer fare over 20 years in low Earth orbit? How does this pressure vessel look? Is it warped? Is it true? And then I'm talking about a purely scientific standpoint. Bring back the toilet. Yes, absolutely. There's something to learn there. Are they irradiated, Jeff? Yeah, how good did they do at bouncing the radiation in low Earth orbit? What about all the sensing equipment, all the cameras that they have out there? Bring that stuff back down so it can be researched, so it can be taken apart and examined. Could be invaluable for your commercial for the commercial entities that are going to replace this. There's absolutely something to learn from the toilet. How hard would it be to put it in a graveyard orbit and just use it to gather data? The ISS was designed to have people aboard, Pop. It can't really be operated remotely. It needs people on board to be able to do maintenance. Ghost riding the ISS to a higher orbit, and like I said, I don't like it when NASA makes excuses. That's not making an excuse. That's just stupid. That's like saying, oh, you know, we'll take this cruise ship, right? That's designed to have a complement of 500 people on it, and you know, we want to retire it, and we might want to use it later. So let's just put it out on the high seas and just, you know, it has GPS and propulsion. It'll be fine. Just leave it there and it'll just kind of sit there. That's a bad idea. That's not even like making an excuse. That's not smart. They have stuff lined up to replace it all systems. There's actually, once again, there's leeway in the contract for when they're actually going to do the deorbit burn. Because they basically won't until there is an operational replacement. It's built into the contract structure, which is great. But Ken Kremer from Space Up Close did ask a very pertinent question, which they basically gave a non-answer to. There is multiple programs. So the ISS is not going to be replaced by one particular entity. It's going to be replaced by multiple ones. The idea is that NASA is moving low Earth orbit to the commercial sector. So multiple commercial space stations will be replacing the ISS, not one particular one. There are 2 NASA programs right now to basically do this. One of them is the Axiom Station. The Axiom Station, Axiom is a private spaceflight organization that is mostly founded by NASA astronauts. Yeah. The Axiom Station will be built onto the ISS. So the ISS is actually going to get bigger before 2030. Here. The Axiom Station will consist of 3 principal modules here, and then eventually it'll move to 5. That's what the Axiom Station is supposed to look like right there. And what Axiom and NASA have come to an agreement to build the Axiom Station so Axiom can learn how to do this, because their station uses modular components. Just they're derived from the ISS. Let's be real. Axiom is going to build their station onto the front of the ISS like that. Now, I have some theories. Here. I'll get into that more in a second. Axiom is one of the solutions. Before the ISS is deorbited, they will separate Axiom from the ISS, and the Axiom Station will free float and be the de facto replacement. NASA is also working on another program. This is the second thing. NASA's working on another program called the Commercial Low Earth Orbit Destinations Program, or CLEOD for short. Commercial Low Earth Orbit Destinations is grouping with a bunch of commercial spaceflight providers to build multiple commercial space stations that NASA can send their astronauts to do scientific research. Basically doing exactly what they do with the ISS right now, except NASA is not operating the station. NASA's doing the science on the station, and the commercial partners are operating. Does it have unbreakable toilet? I mean, PY, it's interesting that you say that. I've never heard of the Russian toilet breaking. It's good toilet. For a show toilet. Hopefully it has good toilet. Nokia toilet. Yeah, we need the fins to make a 3310 toilet. EJ, you got me into Derail Valley in VR and it's consumed my life. Sorry, Fancy. Gotta go for now. Have a good day. Trains are awesome, dude. Trains are amazing. We do it outside. Что? Yeah. Okay. In Russia, toilet flushes you. What are the spider-shaped leg things on the left side of the Axiom pic? They're covers for the cupola module. They're window shutters. It's like the ISS growing a baby and sending its kid off to the real world. Yep. So commercial low Earth orbit destinations is the other solution. But here's the thing: commercial low Earth orbit destinations is severely underfunded. Yeah, severely. Give me 1 second. Have you played NCAA 25 yet? What? Why would I play that? So if we bring some choice modules back down, then send the rest off on a 100-year trip toward Pluto, it will be useless, but it will not be destroyed completely and may end up being useful in the future. Paul, the ISS is the size of a soccer field or the rest of the world football field or a hand-egg field. I don't care. American football, European football, all made in Taiwan. No, wait. Anyway. It's gigantic. It's 400 plus tons. We don't have anything that could move it anywhere but just in a little bit of a higher orbit. Seriously, we don't have that type of technology. Not because we can't make it. Just because why? The ISS, like I said, think of the ISS not necessarily as a spaceship. I know NASA says it's a spaceship. The ISS is its own spacecraft. I mean, technically that's a way to say it, but that's like calling an oil rig a cruise ship. Does an oil rig have everything on it for a crew to stay on it for long periods of time and drill for oil? Yes, absolutely. Does that make it a cruise ship? No. Fair enough. My bad. No. Don't apologize. It's a good question. Yeah, long story short, it's not really designed to be put under a thrust load like that, and nor do we have a module that could boost it towards Pluto. Dude, we have trouble moving a probe the size of a car's engine out to Pluto nowadays. That's extremely hard to do. That's a long way away. Think about it like, actually, no, that's a bad example. Long story short, there's planets that can get in the way. And even if the planet isn't physically in the way, its gravitational pull is. So, like, if we just, launch something and aimed at Pluto, you got to aim at where Pluto is going to be. And then you got to hope that Jupiter, Saturn, Neptune, the asteroid belt, Ceres, Mars, you got to hope that those don't get in the way. If they even get close, it'll pull the spacecraft off trajectory. Hard thing to do. That's what PC simulations are for. Yeah. Yeah. Sure. No simulation is going to be high enough fidelity to be able to predict the nature of orbital perturbations over a period of time. You know where the planets are. You can use a trajectory modification, but there's galactic cosmic waves. There's solar wind that you have to take into account. There's windage. There's a bunch of things. Yeah, we could do it, but here's the other part, Gentis. Okay, great. We have a computer simulation for this great trajectory for launching the ISS towards Pluto. What? Okay, here, look. Let me explain it this way. All right, so this is what I'm about to show you. Looks like a subway map. To be honest with you, it looks like a subway map, but it's not. This is what's called the delta V chart. Okay, this is a delta V map. What does a delta V map do? Let me explain. So, what is this map showing? Now, in order to understand what this map is doing, you have to understand that spacecraft's range, how far it can go, is not measured in distance. Spacecraft range is measured in acceleration. It's not how far you can go, it's how fast you can go. I.e., if your spacecraft can change its velocity by 1,000 meters a second, right, you can go a lot further. 1 kilometer a second is a big deal, but now you'll be able to go further. You can get further away from whatever you're orbiting around. This is basic orbital mechanics, right? So look at the delta V map. So let's find Pluto on our delta V map. Heck, yeah, where is it? So there's Venus, Mercury, Jupiter, Saturn, Titan, Uranus, Neptune. Titan? Callisto, Ganymede, Europa, Io, Deimos, Phobos, Mars, Moon, geostationary. It didn't include Pluto in this map. Okay, screw it. We'll use the Moon. So, let's look at this map. Earth is down here. These are in kilometers a second. So, we want to get to Moon capture and then relative circularization. So that's 680 meters a second. Plus 140 meters a second. All right? Now, you would need to transfer the ISS from Earth to what's called a translunar injection, or TLI. That's not easy to do. That's 680 meters a second, right? And then to get the transfer and capture, you add another 2.4 kilometers a second. And then right here, low orbit, 250 kilometers. That's basically where the ISS is. So the heck with Pluto. Let's just say to low lunar orbit, or LLO for short. So 2.4 plus 0.7, right? 3,100 kilometers a second. 3,100 meters a second, 3.1 kilometers a second. So that's about 3.3 kilometers a second. Now, plus 0.68, I'm rounding numbers. We're using float. 4 kilometers a second to get from Earth low orbit to lunar low orbit. Let's just say we don't want to put it in low lunar orbit. Let's say we keep it orbiting high up around the moon. 3,500 meters a second, 3.1 kilometers a second. Okay, so some perspective here. That is a third of the way into orbit if you launched from Earth. To get into low Earth orbit, you need 9,400 meters a second. Okay? To get from low Earth orbit to the moon, you need 3 kilometers a second, or 3,000 meters a second. It's a third of the way. So, taking into account the mass of the ISS is 400 tons. Okay, so now you're going to need something that's going to be able to move this thing pretty reasonably. The reason why is because relative to low Earth orbit, the moon is moving pretty damn fast. Right? Relative to the surface. That's why the moon, you can see it at different points in the sky. It's moving pretty quick. The point is that if you were going to do a trans-Earth injection, or translunar injection, or a TLI style Hohmann transfer, Hohmann transfer is just basically a good way to get there. You have to aim at where the moon is going to be. If you're going to do that on any reasonable schedule, you're going to need a very high thrust to weight ratio. So, the ISS is 400 tons. You're going to need something that's going to be able to accelerate it an extra 3,500 meters a second, right? And something that has enough thrust to move the ISS to move it onto to put it on a high energy transfer. Okay. Now, you could use a low energy transfer, but every second that the ISS is not either at the moon or at Earth, you're running the risk of the space station just coming apart, because no one's going to be on it, presumably, when you're doing this. Right? So, long story short, it takes you would basically need to attach like a Saturn V first stage to the thing to get it to go out to the moon. You'd need something with a lot of delta V and a very high thrust to weight ratio. You'd need something really powerful. The ISS isn't designed to be able to take whatever kind of thrust that is. Now, you could put some type of crazy, like maybe an ion thruster, and do a low energy transfer. That means it would take years to get out to the moon. You could do that. But once again, every second that nobody is on this space station and you're sending it out to the moon is a second where the space station could break. Something could break. Something could fall apart. It could get hit by debris. You don't want that. You don't want an ISS-sized piece of debris floating around in low Earth orbit. That's bad. The Viper mission is dead. NASA ends the Viper project, continues moon exploration. If the ISS was orbiting the moon, could we see it? No. Well, you're saying it's cheaper and easier to throw it away than to build a new one around the moon? No, geek. We're talking about putting it in an orbit around the moon so we could save the thing. What I'm saying is, honestly, getting Starship operational and doing the reverse of the 35 ISS assembly missions that it took to put that thing together would probably be easier than trying to send it to the moon. I still want modules. I want to bring the modules down, at least one, dude. Hey guys, hey guys, hey guys. You remember when I said just a second ago that NASA making excuses is a really, really bad look and really disgusting? Do you want to see why I say that? Following a comprehensive internal review, NASA announced Wednesday its intent to discontinue development of its Volatiles Investigating Polar Exploration rover project. Just for some backstory, Viper was a prospecting probe that was designed to go and find water ice and volatiles on the moon so you could find a good spot to build a base that has good access to water and volatiles that could have rocket propellant. Well, water already does, to be honest with you. Viper was a lunar prospecting rover. NASA stated cost increase, delays to the launch date, and the risk of future cost growth as the reasons to stand down on the mission. The rover was originally planned to launch in late 2023, but in 2022, NASA requested a launch delay to late 2024 to provide more time for pre-flight testing of the astrobotic lander. Since that time, additional schedule and supply chain delays pushed Viper's readiness date to September of 2025, and indefinitely, its commercial lunar payload services launch aboard Astrobotic's Griffin lander has been delayed to a similar time. Continuation of Viper would result in an increased cost that threatens cancellation or disruption to other CLPS missions. NASA has notified Congress of the agency's intent. We are committed to studying and exploring the moon for the benefit of humanity through the CLPS program. The agency has an array of missions planned to look for ice and other resources on the moon over the next 5 years. Our path will make maximum use of that technology and work that went into Viper while preserving critical funds to support our robust lunar portfolio. Moving forward, NASA is planning to disassemble and reuse Viper's instruments and components for future moon missions. Prior to disassembly, NASA will consider expressions of interest from U.S. industry and international partners by Thursday, August 1st for use of the existing Viper rover system at no cost to the government. Oh, great. You're going to pawn it off. Astrobotic will continue its Griffin Mission 1 with its contract with NASA, working towards a launch scheduled for no earlier than fall 2025. Landing without Viper will provide a flight demonstration of the Griffin lander. Fuck you! It's still gonna land? Oh, you guys suck! Excuse my language, I'm sorry. I'll time myself out. Sorry. Sorry, I like to run family friendly during the day, but... Right, Black Ops. Yeah, right, Junie. Yeah, let's just get kicked in the nuts repeatedly as spaceflight fans. Thanks for that. Viper is supposed to land on an astrobotic Griffin lander. NASA just decided that the rover which they've made is going to be too expensive for the lander that Astrobotic is going to make anyway and launch to the moon and land anyway. The rover, which was the lander, which was designed around the rover. Who's making these decisions?
Discovery, go at throttle up.
We need accountability. I'm sick of this. Who's making these decisions? Seriously, I need to know. We need to know. I want to know as a taxpayer who's making these decisions. And I don't like playing that, well, I'm a taxpayer nonsense. This is ridiculous. Keep reading. NASA will pursue alternative methods to accomplish many of Viper's goals and verify the presence of ice at the lunar South Pole. A future CLIPS delivery, the Polar Resources Ice Mining Experiment, Prime 1, scheduled to land in the South Pole during the fourth quarter of 2024, will search for water ice and carry out a resource utilization demonstration using a drill and mass spectrometer to measure the volatile content of subsurface materials. I have thoughts. Sage, what's going on? Thank you for the raid. I'm getting annoyed with NASA again. Snibbles, you know what? Let's just finish this. My opinion's changed between this paragraph and this paragraph, but I'll explain why. But in the meantime, we had a Sage BB raid. Thank you very much. I do appreciate it. Present the news as Bill Nelson. Hey, dude, what did NASA do to piss you off? The gist of it, Sage, is that NASA has a rover that's designed for lunar prospecting, basically built, for the most part. It still needs to be assembled to an extent. There's a picture of it. They are canceling it because it's too expensive. Fun fact, this rover called Viper was supposed to land on the moon using a commercial lander that's being developed by a company out of Pittsburgh called Astrobotic, and they're going to use their Griffin lander to land. They were going to use their Griffin lander to land Viper on the moon, but NASA canceled Viper. But they're still paying Astrobotic to land Griffin Mission 1 on the moon. So NASA canceled the rover, but is not canceling the contract for the lander that's designed to put the rover on the surface. Okay, I have a stupid question, a very stupid question. If this is the case, why not take Prime and put it on Astrobotic's lander? Why not just put that on there? Right? And what? See, here's the thing. This is why making excuses is a bad joke. It's a terrible look, because how do we know Prime? You're not going to say the same thing about Prime 1 at the end of this year. They're doing it for the experience then? Goldfrix, I can't imagine a scenario where you're going to pay a commercial company to build a lander to land a rover on the moon and then not send the rover. What? It was a bad joke. Yeah. Well, I got you. All good. What are we talking about? Politics. Politics sucks. Private industry is the only way. Well, Paul, give me a second, dude. Before we get rowdy in the chat. Yeah, I try to refrain from political banter in here. Keep. If you're going to talk politics, it has to be about space flight policy. That's the only thing. So saying, "Oh, well, this money is going there," that's no. That's no good, dude. Don't do that in here. I'm asking nicely. Like most people would just be like, ban you and get out of here. But like, just bear with me. Hear me out. I have some thoughts here. Let me finish reading this train wreck of a press release. Additionally, future instruments are as part of NASA's crewed missions. For example, the Lunar Terrain Vehicle will allow for mobile observation of volatile. Okay. Yeah, you're going to use Viper's equipment on future missions. Great, good. Copium. Viper rover was designed to search Earth's moon for ice and other potential resources and support NASA's commitment to study the moon and help unravel some of the greatest mysteries of our solar system. Through NASA's lunar initiatives, including the Artemis human missions and CLIPS, NASA is exploring more of the moon than ever before, using highly trained astronauts, advanced robotics, and U.S. commercial providers and international partners. Okay, I'm calling BS on this. Which one of these things is exploring the moon right now? Highly trained astronauts. Hard to explore the moon when you're not there. Advanced robotics. What event? You just canceled the rover. U.S. commercial providers. Okay. Yeah, where are those at? Last time I checked, we haven't done that. And international partners. Okay. What? Okay, there are some international payloads that went to the moon, like the Chinese. Oh, we don't work with them. Which one of these things are you using to explore the moon? We're exploring the moon more than ever before. That's a bold statement, considering we've put people on the surface in the past. That is somehow implying that. Hey, Paul. Thanks for that tier 1 sub, brother. I appreciate it. Thanks, man. Like I said, just hear me out. But stick to spaceflight policy in here, right? I don't. It's easy for it to go off the rails, dude. And to be honest, I'm kind of going off the rails right now. I'm pretty pissed at NASA. I'm not gonna lie to you. Anyway, yeah, the commercial providers, the IM-1 mission. That's the only one I can think of. The intuitive machines. And I like intuitive. Intuitive's good. That's a good point, guys. Yeah, so which one? Yeah, so flying a rover that landed and fell over is exploring the moon more than putting boots on the surface of the moon is kind of a bold statement, don't you think? That's kind of stupid. Yeah, exactly, Dark Matter. That's my question. There is the Lunar Reconnaissance Orbiter, but the program that was a part of was canceled a long time ago. That was part of the Constellation program. And that's the thing that found water ice on the moon. This is fine. It's fine. It's fine. Okay. Here are my thoughts. All right. So, to recap here, just in case anybody was wondering. That project got canceled too, Dark Matter. Dear Moon? Yeah. Okay. Now, to be fair, that's an entirely commercial endeavor. But anyway. Yes, Dear Moon is canceled. That's correct, Bob. I guess the people funding the mission decided that they wouldn't be going to the moon anytime soon. And that because of this, because it's not happening anytime soon, don't worry about it. I don't want to do it. All right. Anyway, Have you seen the speculated K-pop? I went over that on Space News yesterday. So here are my thoughts. Okay. The CLPS program, Commercial Lunar Payload Services, right? The CLPS program is basically NASA using the commercial markets to make small rovers to go and learn about the surface of the moon before we send people back there, right? Pretty straightforward stuff. Now, the CLPS program has a bunch of different contracts from a ton of different commercial providers. Intuitive Machines is a CLPS. The IM-1 mission was a CLPS mission. Astrobotics Peregrine lander, that's a CLPS mission. We're actually starting to see some lunar exploration here. Astrobotics Griffin lander is part of CLPS. Actually, CLPS has produced some decently fruitful results. However, I would be remiss to mention that if Viper had a redundant mission this entire time, why did Viper exist in the first place? It was one of the bigger points, Beefy. Yeah. Viper was like the flagship mission for the Commercial Lunar Payload Services. If it had a redundant mission, which I did hear about, called the Polar Resources Ice Mining Experiment, if it had a mission that's designed to do exactly the same thing, why did Viper exist in the first place? Or, conversely, why does Prime exist? Where did that mission come from? Someone is snoring in the NASA conference right now. Look, I'll get down to brass tacks. Let me explain. I don't mind commercial lunar payload services. I don't mind using contracted services at all. I personally think that lunar exploration is not ready for the commercial market. Why do you ask? How's that commercial market working with low Earth orbit right now? I don't think the commercial market for even low Earth orbit, well, very healthy right now, is big enough or robust enough to be able to branch out to contracted lunar services. Now, I wouldn't have said that at the time when when those contracts were appointed, but also here we are. Starting to cancel commercial lunar payload services, which was the entire point of commercial lunar payload services was that it was supposed to be a low-cost solution. So why are we making two rovers that do the same thing when cost is a problem here? Because clearly cost is a problem. That's the whole impetus for canceling Viper. Why not just make two of the same rover and have it launch on two different landers? The thoughts that I have are why NASA is... It's been like this since the end of the shuttle program. There's no unifying freaking integrated mission plan. They're just shooting from the hip. Commercialize that lander. Commercialize that rover. Let's save some money this way. Commercialize the lunar lander. Oh wait, no, we didn't want that lunar lander. Commercialize another lunar lander. Look at how much progress we're making. It's been like this. There's no overarching plan. The Artemis program might go to the moon. Yeah, it's probably going to make Gateway. You're going to use the Starship HLS for a couple of landings, and then you'll switch to, a different commercial lander. How stupid does that sound? Now, don't get me wrong. I understand redundant dissimilar architecture. I understand that. That's fair. You want two landers is better than one all day. But also at the same time, you can't make the argument that commercial is going to be cheaper and then field two landers at twice the price. Not twice the price, but why have one lander when you could have two for twice the price? Like, you have totally different architectures to be able to get to the surface of the moon. Now, one could make the argument, right? You could make the argument that that's going to build out the robustness that in the commercial market that you're asking for. Sure. But that's building a robust cislunar economy. Arguably, because you need to get to low Earth orbit before you try anything near the moon, right? You have to get into orbit first before you go out to the moon. We learned that in the 1960s. If your cislunar economy, cislunar basically means the area around the moon, basically anything that's between the Earth and the moon, right? If you're working on building a robust commercial market for lunar economics, right, it best be built on a rock-solid foundation for low Earth orbit. Probably because every large-scale integrated plan has been torpedoed since Apollo. If you don't count Apollo as being torpedoed, which I honestly would. Oculix, this project, yeah, exactly. That's the brass tacks. Look, I understand cost overruns, etc., etc. Now, once again, I'll ask this one more time. Okay, look. The rover was originally planned to launch in 2023, but in 2022, NASA requested a launch date of 2024 to provide more time for pre-flight testing of the astrobotic lander. Since that time, additional schedule and supply chain delays pushed Viper's readiness date to September 2025, and independently, its CLIPS commercial lunar payload services launch aboard astrobotic Griffin lander has been delayed to a similar time. Continuation of Viper would result in an increased cost that threatens the cancellation or disruption of other CLIPS missions. Okay. Yeah, they didn't. Okay. I lost my train of thought because what I was going to say is that they're going to say it's too expensive. An increased cost. I mean, they didn't say it exactly, so my point in that regard is kind of moot. But NASA has lacked an integrated plan for a long time. And it seems like there's low risk with these commercial missions, right? Low risk, so if one of them fails, just cancel it and use another one, right? But I would make the argument that you're getting rid of Viper. Astrobotic's still going to build the Griffin lander that's designed to land Viper, which is canceled. So what the hell is Astrobotic going to use that lander, that Griffin lander for? Where's the market? What's the market for it? Launching Prime? I'm pretty sure that other redundant rover that I was talking about is launching on something different. So now NASA basically paid Astrobotic to build this awesome thing that's designed to basically move a go-kart sized lander down to the moon to search for ice. Is there any market for that at all? This is what I'm talking about, dude. I don't mind building out a healthy lunar economy, but it has to be built on some semblance of market demand for commercialization to make sense. Excuse my ignorance, but how would storing an already built lander in a hangar be expensive? No. They say that launching it would be too expensive, Lava. Launching it would be too expensive, and it would the increased cost would threaten other commercial lunar payload services missions. Tight budget. Commercial lunar payload services, firm fixed price. Once again, you're setting these companies up to fail. You're setting them up to fail by doing this, by trying to build a lunar economy off of a low Earth orbit economy when it's not strong enough. You don't go to bear fruit from a tree that you grow when the freaking tree fruit isn't ripe. This is counting your chickens before they hatch, and canceling Viper is a symptom of a much bigger problem. The bigger problem is that NASA has no syndicated, there's no goal. There's no goal here. There's no overarching goal. You know, Viper was supposed to get up there and prospect for ice in preparation for a lunar mission. But, Orion has life support system problems, so we're going to delay our lunar landing to 2026, 2027, somewhere around there. So Viper's already too expensive, so there's no need for it. We have a redundant rover somewhere else. It's fragmented. It's ridiculous. There needs to be an integrated architecture like the Surveyor and Apollo programs. The Surveyor program and the Ranger program were programs to do unmanned robotic exploration of the moon in preparation for the Apollo missions. Now, here's the thing. Surveyor, there was a bunch of them. They made a bunch of them. They made a bunch of the same thing multiple times. No redundancy, right? And launched one, and it kind of worked, and then launched one, and then it didn't work, and then launched one, and it worked, and then launched another one, and it worked, launched another one, and it worked, launched another one, and it worked. With no dissimilar redundancy. The reason why that's a good idea in this particular case is because there was no market for sending anything to the moon. And I'd argue that there still isn't a market until we send people out there. Right? The fact that they have two rovers that are completely dissimilar architecture that are designed to do the exact same thing, and one of them had scheduling risks, which is always a thing, right? It went too far, and they said the cost overlap would screw the other rover. Why didn't you just make one? Why didn't you just make one? We could have two Viper rovers right now, and there would be no cost overrun, and you could still launch them on a reasonable schedule. This is something that I called Clips a good idea, and I still think it is. I think it's a great idea, but why do we have redundant capability here? We don't, I think it's a very valid argument, because if they were just willing to just piss away money, and then when the rover didn't meet its scheduling goals, just get rid of it, right? When you had a redundant rover waiting in the wings the entire time, why would you do that way? That's a really stupid. That's a really good way. Oh, great! You're using commercial. You're using commercial contract. There's no way that this is less expensive than if we contracted NASA's Science Mission Directorate in JPL to freaking make a bunch of prospecting rovers. I'm sorry, there's not. And that's what I mean. It's too expensive. Its costs could overrun it. What is it too expensive compared to? The other lunar rover that we have? I mean, clearly you do. If it's too expensive compared to the other lunar rover, why didn't you just make that rover in the first place? I'm sorry. It's very frustrating. It's a symptom of a much bigger problem. NASA has no integrated plan. There's no integrated plan. They tried to do an integrated plan. But because the money and the funding wasn't there, they had to commercialize the landers and the prospecting rovers. And then they shorted the human spaceflight part of the Artemis program, and now Orion has problems with its life support system because I don't think it was sufficiently tested. Question, could the money overrun that is hinted at be not the rover end as built, but the launch part? It could be bloody. I don't know for sure, but I highly doubt it. Yeah, and they're still... Dude, that's the part that pisses me off the most. They're still paying for the launch and the lander. The lander that was built to launch the stupid rover there. So Astrobotic has just built this entire lander around a rover, right? And you decide, they decide we're not going to do that, right? They decide we're not going to launch the rover. And now what? Okay, you're still going to pay them to land an empty, dude. That is Probably because of contract, same as that test stand. Well, Aqualex, I would make the argument that no cost overrun would be comparable in cost compared to the scientific benefit that you would gain from having 2 prospecting rovers on the moon instead of 1. I think my biggest problem with this is that NASA is putting a price on scientific understanding, which is just infuriating. Nothing is going in place, Nick Tide. Actually, nothing. They're going to launch the lander that Viper was supposed to be on empty and landed on the moon empty. See what I mean when I say NASA making excuses is disgusting? It's gross. It's gross. Once again, it's very, very clear to me that, and I'm only being critical because I love NASA. I'm not trying to be a jerk. Like, and I understand you're going to have your hands tied, the bureaucratic process, blah, 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 blah. Well, there's a time when the bureaucratic process worked and you put people on the moon. Yeah, making that argument, I always thought that argument was stupid. You know, people say, oh, NASA's just a jobs program. Well, yeah, we've used that jobs program to put 6 American flags on the moon. I don't care if it's a job program I don't care if it's a jobs program as long as it provides results. So clearly there is a way to get this process to work, but it's very clear to me that everyone at NASA is just buying for table scraps. They're buying for table scraps because there's no plan. There's no fragmented plan. You're not organizing the Science Mission Directorate with a stated goal, nor are you doing that with human exploration operations, nor are you doing that with exploration ground systems. It's just everybody's kind of vying for just a little bit more funding here and there. It's gross. It's disgusting. It's disgusting. If people want to run NASA like a business, go join the private sector. Get the frick out. I hate it when people say, oh, we're not doing this super advanced scientific exploration because it's too expensive. It's the stupid bullcrap argument people make with SLS all the time. Oh, SLS is too expensive. Compared to what? Our other moon rocket? Starship is unproven. And the second that Starship does everything that SLS can do and more, then frick it. Yeah, okay, I agree with you. But until that point, what? Our other moon rocket? Oh, where's that at? Oh, yeah, there's 3 of them sitting in museums that are 50 frigging years old. What are you comparing it to that? Because that's way more expensive. People don't realize that the Apollo had a blank check. They had a blank check to get it done. And it got done. You know why? Because they didn't do the cost analysis on it until after. They had a goal, they completed the goal, and then they saw how expensive it was later. Which I would argue is a way better way of doing things for the exact reason, for the specific reason that Apollo arguably accomplished the most scientific understanding and knowledge. The science that we learned and the science that was gathered from the Apollo missions we're still learning from today. That was from 6 lunar landings 50 years ago. Yeah, Rem, it's disgusting. It's gross. Is there any accountability? Is anyone capable of managing a project at this spaceflight outfit? It's always the same thing every time. Like, don't get me wrong, there are NASA missions that are on time. Like, it does happen, but it's once in a blue moon. Is anybody here capable of, like, the other thing is, the answer to that is, I don't know, maybe, probably the people that are good at project management are probably the ones we never hear about, right? Because it's success, you're not going to argue it's survivor's bias. You're not going to argue, that it's bad project management if the mission is successful, right? But also at the same time, see, the flip side of that is that it might not be the project managers. It might not be. Might not be them. Why is that? Well, turns out that putting a price on science is a horrible precedent to set, and NASA constantly makes this mistake. What do I mean by putting a price on science? So this Viper mission. And you guys tell me if this is a reach, okay? I'm actually looking for maybe some dissenting opinion. So speak up if you think it's a little bit of a stretch. I'm going to lay this one on. Viper had a cost. That cost was likely to interfere with other missions, right? That cost would, whatever was enough to basically pull the plug on the mission, which, let's be real, it's the cost. It's the cost. The cost overruns that are associated with not getting the thing launched on time, which I still think is a ridiculous, in this post-COVID economy, that's a ridiculous thing to say. Well, we had supply chain issues due to a global pandemic, so the program is underperforming, so we're going to cancel it. So you're canceling it because of performance that was based off of an effect that was completely out of NASA's control. Great. Good look. But on top of that, you're putting the price on the scientific research that the Viper program would have done, even if it launched later than Prime. Right? No one's going to tell me that launching one rover is going to get us more scientific understanding of how the moon's climate works, or how water ice is accumulated on the moon than two. That's bullcrap. Two rovers prospecting for ice and volatiles is much more likely to find more usable scientific understanding than one. There's no getting around that. The gist of what I'm getting at is that you're inadvertently putting a price on science. So that cost overrun wasn't worth it to the potential scientific understanding of finding volatiles on the moon. You're putting a price on science, and that's disgusting. That is disgusting behavior. Because we're at a point where there's no low-hanging fruit with spaceflight. Suborbital flights, right? One could argue that there's not even a commercial market for that. There's no low-hanging fruit. Orbital rendezvous, right? A space station. There's no low-hanging fruit. All of this has been done already. So the endeavors that NASA is basically by design trying to solve, which is inadvertently exploration, understanding of the sciences, or earth science, planetary science, geological science, atmospheric science to an extent, even though it's mostly NOAA, these problems that NASA is trying to solve are progressively getting more and more difficult to solve, right? There's no low-hanging fruit, okay? Every endeavor that we do from here on out, right? Every endeavor that we do is going to be an expensive endeavor. I don't give a frick what anybody says. It's all going to be expensive. It doesn't matter if you're landing a rover this big on the surface of the moon. It doesn't matter if you're using a commercial partner. It doesn't matter. It's all going to be expensive. So canceling it citing cost is putting a price on scientific understanding. That inadvertently is impeding our progress towards going back to the moon. It's gross. It's disgusting. It still costs money to accomplish. Sorry, but that's just how it is. Yes, NASA project managed absolutely horrendous. Also, yes, NASA needs at least another 10 to 15 billion per year. Well, all right, Hellfish, if you're going to play that game, if you're also going to fall into that trap, you gotta, it's going to cost money to do it. The whole point is for NASA is to develop technologies that are hard to access for the commercial sector to not develop. That's the whole point. their endeavors are going to be difficult by definition. They're going to be expensive by definition. So if you're gonna fall into that same trap, that's fine. All right, if you're gonna fall into that same trap, well, here's the thing. That stop trying to pick the high-hanging fruit for a low-hanging fruit cost. All right? You want to go get the high-hanging fruit, you're going to need a ladder. You know what I mean? If the budget isn't going to be there, stop trying. Because all you're doing is pissing away money on a rover that you're going to design, but you're going to get cold feet at the first sight of sticker shock from some of these missions. You're going to get cold feet, you're going to pull the plug anyway. Well, piss off. Use that on other missions. Honestly, I don't believe it's NASA that's putting the value on knowledge. I think it's people controlling NASA's purse strings, and their behavior has scared away anyone willing to make big plans or good at actual project management. Alex, I think that would be a fair point if it was 1995. That's all that's been happening for the last 30 freaking years. When are we gonna learn?
This is space. I'm in space.
Like, if this happens once or twice, it's not a problem. If it happens once or twice, that's no big deal. This has been happening with spaceflight projects for the last 3 decades. When are we gonna learn? This is the definition of insanity. Hey, Major Postal, gifted 5 subs. Thank you. And a 45-month resub. I appreciate it. Learning was not in the approved budget. It's gross. It's gross. There's no accountability. If the one thing that you could take into account, if the one thing you could take into account is that the money might not be there in the future, why would you even try to do something that would require said money in the future? You have to. The only solution to that problem is to make the missions codependent. Right? We started to see that with CLIPS, which I don't have a problem with. Started to see it. Commercial missions will pave the way for human missions. Then we delayed the human missions. And then on top of that, because of COVID, some of these commercial missions got delayed, so we're starting to pull the plug on stuff. And my argument is that if we have redundant rovers, why did we even spend money on this in the first place? To stimulate some local economy? Pittsburgh isn't known for its aerospace sector. Not to say that that's a bad thing. Do I think Astrobotics should be there? Absolutely. But also, you're setting these companies up to fail if you're going to do stuff like this. So why not just go with a much more integrated architecture? The one thing you could take into account is that your budget is going to get screwed because there's programs that are easy to axe because there's redundancies to the program. You need to come up with a more integrated architecture. We've been falling for this trap for 30 freaking years. Look at the debacle that is Europa Clipper. It's another great example. Aqualux, and that's what I mean. When are you going to learn? The only way that this is really going to work is if we have a more integrated architecture, making payloads dependent on NASA vehicles, like what John Culbertson was trying to do with Europa Clipper. But at the first sight of cost overruns, they said, frick it, move, and they made Europa Clipper dependent on SLS, which is a good idea. And then they didn't even bother making sure they had an SLS to launch Europa Clipper on a reasonable timescale because Europa Clipper is going to Europa. It's a long way away. You have to have a planned launch window or you're going to go to launch and Europa will be nowhere near you. You have to shoot at where it's going to be. That nominal window only comes around once in a blue moon. Actually, less than that. Talking astronomy. It's less than that. So why? Why did we make a program dependent on a launch vehicle and not tell the program that was controlling the launch vehicle that we have this program that is time sensitive? More specifically, SLS and time sensitive don't really go together. What's going on? So Europa Clipper was a fiasco because of the lack of integration there. And that stems to the SLS being not a bad launch vehicle, but just the program is fragmented. It's all over the place. The only healthy solution here is to integrate the programs together. And that starts with more SLS launches, or you know what, frick it doesn't even need to be SLS. Maybe Starship works and does everything that Elon promises, and it's basically the shuttle 2.0. All right, fine. NASA, buy a bunch of Starships, make a bunch of payloads dependent on that. Right? Like, you have to have some integration here, or else you just have a bunch of different NASA facilities just vying for extra money, and then that makes it really easy when these programs inevitably, which are set up to fail from the start, when they do fail, they're easy fruit to pick off. James Webb was a bit of a fiasco too. James Webb cost $6 billion over 20 years. It was supposed to launch in like 2003. The reason why is because the people controlling the project said James Webb is going to depend on super awesome science technology that we don't have yet. We have to develop the super awesome science technology. You put a price on science. How much is it going to cost to develop this super awesome science technology? Probably costs like $1 million. $6 billion later, and 20 years later, the technology is developed. Piss poor project management. Disgusting. It's just, and don't get me wrong, I'm not saying we shouldn't have done it. What I'm saying is, look, if you're going to do something like that, you've got to be in it for the long haul. But we can't be sure that you're going to be in it for the long haul. So the only way, and I would argue that this was a really smart idea, the only way to make it sustainable in the long haul is making it dependent on other programs. James Webb launched on the Ariane 5. Now the Europeans are involved. That was a good idea because that made the program harder to kill. See what I'm talking about? You need more integrated architecture, or you're going to keep seeing cost overruns. You're going to keep seeing, different programs vying for funding. You have to make it into one big thing like the Apollo program. With the Apollo program, the Science Mission Directorate and Human Exploration Operations worked together. They worked together, and look at the result. If we tried to do the Apollo program nowadays, the way that NASA funds these projects, like this, maybe this, maybe this, maybe this, maybe this, maybe this, well, we would have SLS, and that's what we do. How much of the cost overruns caused by improper funding to start with? See, you're saying improper funding. You keep doing that. How do we know that it's going to be improper funding? Because we don't know how much it's going to cost. This is what I'm trying to say. This is what I'm trying to tell you. You don't know how much it's going to cost. So how the frick where do you get off putting a price on it? Anyone? People say SLS is expensive. Like I said, compared to what? What? Compared to what? Is SLS the best rocket around? No. Could Starship potentially be better than it someday? Yeah, sure. Absolutely. Starship is the only one that's even remotely comparable. Except you have constantly said that projects need to have a proper funding curve to actually work. You're twisting my words, and it's pissing me off. I'm not going to lie to you. That proper funding curve is based off of what is needed, not what is budgeted. Important footnote. I don't know if you're doing that on purpose, Hellfish, but it's kind of annoying. The Apollo program was funded on a bell curve. That bell curve was based off of a need. That need was based off of stakeholder expectations. We choose to go to the moon in this decade. Guys, everybody says, oh, we hate cost plus contracts. Apollo was cost plus. So what? I would argue that cost plus is one of the only things to get things done the only good ways to get things done when you don't know the price of what you're trying to do. Where that peak of that bell curve is, Hellfish, is unknown. It's going to cost more money. And now what keeps the contractors from hamstringing NASA? Deadlines and penalties for not reaching these deadlines, which one could make the argument that that's what happened with Viper. There are penalties for not getting this stuff done on time. But it's funny to me because NASA's okay with letting them take their sweet time and launching the rover, and launching the lander, but not following through with the rover? Are you really punishing them at that point? Why not just finish the rover? Sure, new technology can't be predicted. However, when the engineers get proper funding to design, experiment, test, etc., the costs become more and more predictable. Let me just rewind this conversation just to make sure we're on the same page. You said that you have to know what you're going to fund. I say you don't know how much it's going to cost. And then you said, well, yeah, you got to figure it out first. And then the costs become more predictable. So you backtracked what you said, first of all. Second of all, yeah, how do you know how much it's going to take to figure it out? That's what I'm talking about. Like, I honestly don't understand what you're trying to tell me. Like, that makes no sense. There's always going to be an unknown. There's always going to be an unknown cost. To try and say that we can predict it accurately is stupid. The only way to even remotely understand that is to fund stuff on a need basis. Right? Like, that's why I'm like, I don't understand what's going on here. What are you trying to say? Overtime, over budget, under deliver over and over again. There's always going to be unknown unknowns at this point. There's no low hanging fruit, guys. I'm sorry, there isn't. Everything is going to cost. Everything's going to be expensive. We're pushing the boundaries. And to even suggest for a remote second that there is a price on pushing the boundaries is pathetic. Like, maybe in the past I would have been less candid about this. I would have tried to put it a little bit nicer. I've been seeing this behavior personally 10 years into this program, 10 years of covering spaceflight. It's only gotten worse since COVID. You know, and I think, okay, they canceled the X-33, they canceled DCX. There was probably a good reason for it. Even if it was, probably politically motivated, there's probably, like, I get it, there's good reason. No, there isn't. Look, you're trying to agree with you. It's just a rule for projects. They're only going to be more expensive than expected. Bingo. When you build a budget, you should try to build in an overrun to try to be safe. Yeah, Geos, the problem is with spaceflight, that safe margin, how can you predict it? You can't. You can't predict how much it's going to cost. I'm sorry, we can't predict the future. Like, you can't. There's no way. The only way to accurately predict it is to understand that you can't accurately predict it. The second that NASA starts doing that is the second we stop seeing. I'm going to be candid again. The second that NASA starts doing that is the second we stop seeing projects canceled for horse shit reasons. ridiculous, dude. I'm sorry. This pisses me off. It's something that I hold very near and dear to my heart. Yeah, Aqualix, yeah, I know. There's a reason why Uncle Sam, DARPA, everybody else has a big budget. Like, the F-35's budget ballooned to over $1 trillion, invested. And see, a lot of people say, oh, there's too much money. All right, yeah, compared to what? Compared to the other JSF that exists? Compared to what? The other F-35? What are you comparing it to? A Sukhoi 57? That thing's a piece of shit compared to an F-35. Yeah, there, I said it. It's a piece of junk. Compared to what? Compared to what? The whole point of the F-35 program is raising the bar and making a next-generation fighter. If anybody goes to do that and doesn't think that they're going to pay an arm and a leg for it, for pushing the boundaries to maintain strategic capability that's higher than your potential adversaries, is off their freaking rocker. I would say that person has no idea what they're talking about. Same with the F-22. That's what I mean, man. Like, you're not going to push the boundary. The only way to push the boundaries and do it at least with at least a modicum of fiscal conservancy, right, is to understand that project costs can balloon. It happens. We don't seem to understand that. There seems to, once again, the communication process is broken down. Oh, the two youths. What? Bro, Joe Kearns is talking right now. Through June 2024, Kearns said NASA has spent about $450 million on the Viper project. He says Griffin will still carry its planned commercial payloads and can go out and solicit more commercial payloads. NASA will fly a mass simulator to approximate the Viper payload. They may know that's the case, but the general public still gets sticker shock and is upset that their tax money is misused. They're only upset, Ethereal, you're right. The only time, as a taxpayer, and keep in mind I could be a little bit biased as a U.S. taxpayer, the only time I get upset with NASA's funding is when they do shit like this. That's the only time I would think it's a waste. And I think that's a vast majority of Americans would agree with me on that. I don't see anybody here complaining about the cost of the Apollo program. You know why? It was expensive, but it accomplished something. Remember, the other stakeholder expectation is that NASA's supposed to be pushing the forefront as a export to our adversaries that, look, we can land people on the moon. You can't do that. There is a factor of pride associated here with this. And I think that's an important thing to understand. I think as long as stuff gets done, as long as we can point at and say, yeah, NASA's doing awesome stuff, that's cool. I've never seen anybody say NASA should get less money because they're doing awesome stuff. NASA is the one that's saying that, which is stupid. Yeah, they paid $450 million to launch a brick of metal to the, or a cube of metal to the fucking moon. Remember how I just said a second ago how there's an element of national pride to this? The Chang'e 5 lander landed. Chinese are doing sample return. We send a lander with no rover on it. That's disgusting. It's disgusting. It's unacceptable. I'm sorry. It's unacceptable. I'm sorry. Like, unacceptable. What do you think that bell curve is, Hellfish? Do you even listen to what I say? You're making the argument that the costs need to be free-flowing. You basically got to give a blank check at the beginning, but as you get further and further into the program, the cost goes down. That is it. Yes, that's how this works. That initial period is the run up to the top of the bell curve, dude. What the hell do you think that is? I'm very confused. You're saying, EJ, I disagree, but I agree. All right. How was KSP? I played KSP for a second monoprop, and then NASA decided it was going to piss me off today. For multiple reasons. No, Elvish, I get what you're trying to say, but I think it's semantics. I think the gist of what we're saying is the same thing. So that's what I'm getting at. That uphill ride on that bell curve of funding needs to be on an on-need basis. If it isn't, you're setting yourself up for failure. Is that a better way to explain it? I'm most disgusted about how Rule 8 gets to cancel cool NASA things and then outrage theater about it to get the public to blame NASA instead. Aqualix, I get it, but how many times, I will ask again, maybe I missed your reply. How many times are we going to make this? If you know that in 4 years, the funding might not be there because of a presidential change or shifted policy or whatever, why are we trying to make programs that go that far? See what I'm saying? Does that make sense? Does this... The one thing that NASA needs to take into account, is that your funding is volatile. Your funding is very volatile. And it seems like they don't. Like, that, you don't know the cost. The money might not even be there. Like, but we still push these projects through, and it seems like it succeeds in spite of what's going on. But once again, dude, I would contend to say that there was a time where the system worked, and it worked great. Gave us the Apollo program, gave us the Mercury program, gave us the Gemini program. Look, man, if the system hasn't changed, that means we have. That means we're doing something different than how we did it back in the day. All right? If the framework hasn't changed at all, what has? I don't want to remind you that they burned 30 billion on Constellation. Poof, gone. They didn't burn 30 billion on Constellation. They burned like 5 billion and then canceled it, saying it was going to cost another 30 billion, and then funded SLS for $30 billion to do less. SLS doesn't have an integrated program. Maybe we'll go to the moon. Maybe we'll land on it. Maybe we'll build Gateway. That maybe, that uncertainty, that lack of integration with other programs is why it's ended up costing more. I guarantee you. They could have designed Constellation for not nearly, about the same. So we could have gotten 2 launch vehicles for $30 billion and a robust integrated program architecture that gets people back to the moon on a reasonable schedule, setting us up with long-term goals for vehicles that will send us ultimately to Mars with transfer vehicles and technology to support it. Or we could save some money and build 1 launch vehicle with no goals, except you don't save money when you do that. You end up spending the same amount of money on 1 vehicle instead of 2 with a robust integrated architecture. Integrated architecture like Constellation, with clear-cut goals, like Constellation, like Apollo, like Gemini. Those are the programs that always end up being the best bang for your buck, despite potential cost overruns. See what I mean? I want Coco. I gotta go poopy. So Artemis is a waste of tax dollars. It's not a waste of tax dollars because it exists, Nova. It's a waste of, I'd say, if you compare it to the potential of Constellation and where Constellation was going to go, I contend to say that for the same price, we could have had 2 launch vehicles. NASA would not have to rely on commercial customers to get to the ISS, and NASA would also be basically setting up for a lunar base at this time. And I can say that saying that is based off of the fact of the uncertainty of funding, like what I'm talking about. So let me put it to you like this. With the Constellation program, we were supposed to basically go back, restart lunar exploration in the late 20-teens into the 2020s. That was kind of the time scale for exploring the moon. So let's take into account that uncertainty. They said it's going to launch in 2019. Take into account worst case funding scenario, we'd be exploring the moon right now. Not getting ready to explore the moon, or getting ready to launch the mission that's going to get ready to explore the moon, which is basically what we're doing. Can I ask, why did we scrap the shuttles? The shuttle program, basically, after Challenger, Geo was begging to be axed. The only reason that it didn't was because we wanted to keep it going, because it kept a lot of people employed. We never utilized any of the shuttle's capabilities that we paid for as taxpayers to be developed. The robotic arm, building space stations, building transfer vehicles. The shuttle was supposed to be able to assemble spacecraft that were designed to send us back to the moon in space and then bring them back down. And it was going to be able to do that through high frequency of launches. Well, we kicked that plan out the window after Challenger because we needed to make it more safe. We needed to make it more safe, so we launched it less. You heard that right. We needed to make it safer, so we launched it less. Safety and the probability of loss of crew, or just LOC, or PLOC, I think is what NASA calls it. Probability of loss of crew is usually derived from some semblance of empirical evidence. We only could figure out how safe the shuttle was after launching it a lot of times. So we decided to make it safer by launching it less. Dude, this is what I mean. I'm pissed about Viper, but that kind of mentality has been going on at NASA for a lot longer than, and most of us have been here. Who here was alive in 1986? I'm sure a good majority of you were, to be honest with you, but there's a lot of new spaceflight fans here too. You see what I'm talking about? We shoot ourselves in the foot. We've been doing it since the Apollo program. And the shuttle was going to buck that trend in the early 80s, but the second we started not listening to engineers, which is a little bit of a side note, not listening to engineers and not pushing the boundary because of budget and cost overruns and delays to the program, we ended up killing 7 astronauts and arguably making the shuttle program way less safer. I'd argue that the reason why Columbia happened, the reason why STS-107 happened, came from launching the shuttle less, not more. So to answer your question, Gio, why did we get rid of the shuttles? We got rid of the shuttles because they were seen as too much for what NASA was trying to do at the time, and they were old, whatever that means. Saying NASA should take more risks. I'm saying that risk is not necessarily correlated to astronaut lives, Pigeon. If you come up with a good integrated architecture, like sending a probe before you send a person, you can buy down that risk inadvertently, and you could leverage the commercial market to do it, or you could come up with your own in-house programs to do the same thing. Buy the launch service, whatever. I became a spaceflight fan with the Artemis 1 launch, so I'm very new. No problem, Ethereal. You're in the right place if you want to learn. Post again if you don't mind. Worth a look. To answer your question directly to me, I think it's because the only solution to that level of volatility is to do nothing, and it's NASA's mandate to try. No one goes to work at NASA to not try and do cool things. My argument to that, Aqualix, yes, I think that's a good point. That's a very good point. My argument to that is, where's NASA's Falcon 9? Where's your Falcon 9? Where's NASA's Falcon 9? Oh, wait, they tried to develop one in the 90s and it got axed because of cost overruns. It's weird. We had one, it was called Venture Star. Guys, you know, a lot of people are going to say, oh, it's the politicians or it's the bureaucrats. Dude, everybody knows that bureaucracy can cripple an organization. Everyone knows that. Even the people at NASA know that. Everybody knows that the political winds can do the same thing. I refuse to believe there is not a solution to this problem, but I'm not going to sit here and be quiet every time NASA gets burned by this exact thing. At some point, you're going to have to learn to take into account that this can happen. The only way to buck that trend is to make a program that is so tightly wound together that canceling one component will screw up every other component. And that'll get the bureaucrats and the politicians working for you to defend the program instead of cancel it. And now, before you say, EJ, that'll never happen. Oh, that's bullshit. Look at SLS. SLS is arguably one of the most sustainable programs that NASA has ever had. SLS has been going since 2014, 10 years. One launch. So it's very clear that this program can work. It's very clear that you can use the bureaucrats and politicians to your advantage. It's very clear that I mean, obviously the Apollo program too. Apollo program, people say it's not sustainable. I say that's bullshit. It's absolutely sustainable. It only was sustainable because we decided it wasn't arbitrarily. They didn't stop Rule 8 in the past. You know this. Yet something like SLS exists. It's clearly, we can clearly have sustainable spaceflight. My one thing is a tightly wound and integrated system, an integrated architecture. You have something that does what SLS does, which is designed to appease a majority of politicians to keep it funding. If you did that with more programs across the Science Mission Directorate, Earth Observation Mission Directorate, planetary, exploration ground systems, if you had a more tightly wound program that brought all of the NASA centers together, not just human exploration operations, there's arguably, from a Science Mission Directorate point of view, there's no need for SLS. Which is why I think a lot of people argue that from a scientific standpoint, that's not needed. What does that vehicle do? Nothing. Right? But if you try to wind the programs together and make them work, make an integrated system that works, where everybody works together, you're going to create that political and bureaucratic sustainability, and you're also going to do stuff. When those two things align, right? The funding is always there, man. It's always there. Get SLS. Pump more and more funding into it to do nothing. So what is it lacking? Integrated architecture. Why has no one thought of this? Why nobody has thought of this? I have no idea. I can't figure it out. So where's Constellation? Constellation was plenty integrated and still canceled. I would argue that there were some unconstitutional approaches to canceling Constellation. The avenue for canceling Constellation didn't exist by conventional congressional legality. That's what I would argue. You know how I know? That's the reason why we got SLS. Just saying. So on the side note, NASA just paid SpaceX $250,000 for a special study for emergency response. Yeah, okay, Hellfish. NASA doesn't get the money for allowing proper bell curve. Their share of the budget drops every single year. Simply raising that share back to, say, 2008 would allow NASA much more leeway in developing these unknowns. I think that's fair, but Hellfish, the reason why I think that's a little bonkers is because we're never going to do that. You can't propose a ridiculous budget this is what I mean, dude. If they're willing to pull the plug on a program that's slightly overperforming, if you went through the avenues to try and get NASA more funding and you said, oh, double NASA's budget because every program needs more money, that is getting bureaucrats and politicians to work against you, not for you. See what I'm talking about? You're going against the grain doing something like that. If you go and propose a mission architecture that brings jobs to congressional districts over time, like what SLS does, and an integrated architecture with clear-cut deadlines and goals, every politician is going to vote for more funding. This is how the Apollo program worked. Every one of the lower 48 states contributed to the Apollo program in one way, shape, or form, some more than others. This is how they were able to get it done. Contract subnote is under commercial crew. The same contract was handed out during the Soyuz leak fiasco. So on side notes, NASA just paid SpaceX $250K for a special study for emergency response. Lovely. Bill has completely failed on that front. Correct. Politics have changed a lot in 50 years. Sure, of course, Fish. You could, but dude, you're right. I know you're right, but there's no way to quantify that. There's no way to say that without making a freaking enemy. So you're already trying to get NASA's funding increased with one hand tied behind your back. There is no way to say that without pissing someone off. That, once again, that doesn't get politicians to work for you. Being divisive gets more people to work against you. NASA needs to make politicians to need them. That way they fight for NASA. That's what James Webb was so ridiculously good at, Geek. That's what they did during the Apollo program. We can't just blame it on a boogeyman. Saying the politics have changed so it's harder to do stuff at NASA is just as absurd to me as saying, oh, well, we can't do it because it's too expensive. Saying it's too expensive implies there is a market demand for it, implies there's a unit price, it implies that you're comparing that unit price to your current program. That's why, once again, I always think it's absurd when somebody says SLS is too expensive. Yeah, compared to what? The other moon rocket that way? Oh, wait, we don't have that. How do you know? How do you know it's more expensive? You're building a rocket for a market that doesn't exist. So expense is really hard to quantify. It leaves it subjective. And that subjectivity allows, you're basically giving people an avenue to cancel it, or at least call for cancellation, or defund it. Jim did that, Nova. That's why I called it out when I saw it. Jim did not give a frick. Dude, that guy's as right-wing as they come. He didn't care. He worked with everybody to get NASA more funding because he was given a job and a task. And I'll be damned, I don't think Jim seems like the kind of guy to fail at getting the job done. Guy was a freaking Navy pilot. Carrier landings. He has like 3,000 hours in what is it, Growlers and Hawkeyes? He's a Navy pilot. He ain't in the business of not getting it done. Give me a break. He put his job and getting his job done above everything else, and that's why I liked him. That's why I think he did a great thing. He worked with everyone. You know, Jim, you saw Jim over at NASA Ames talking to his political constituents from California over there. Jim being from Oklahoma, I'm not entirely sure they see eye to eye on a lot of things. But he's willing to toss that out the door to get stuff done. The mission is tantamount, absolutely. The third tower section is queued up for stacking. Actually, Journey, you know what? Now's a really good idea to probably mention SpaceX. The reason why SpaceX gets stuff done is because they have a clear-cut goal. Elon has been very straightforward, and I get it. Some people like him, some people hate him. This isn't an avenue to talk about whether you like Elon Musk or not, okay? Please, spare me. It's a stream about spaceflight, okay? Now, with that being said, Elon has been very clear about SpaceX's stakeholder expectations. What's the stated mission statement and goal of the company? Now, in terms of rocket engineering, that would be a stakeholder expectation. SpaceX's stated goal is to develop a transportation system that will not sustainably, that will get people to the surface and Mars robustly, let's say. That's always been their stated goal. Develop spaceflight technologies to support a colony on Mars. That's always been their goal. He's been saying that for 20 years. You have to have a stated goal. And the reason SpaceX beats that into your head if you work there. That's the stated goal. Don't lose sight of the end goal. Keep your eyes on the prize. And that's one of the reasons why SpaceX has been so successful, right? That's not necessarily a commercial or public space program thing. That's just having good stated goals. Does the Artemis program have those stated goals? The Artemis program is maybe we'll send people back to the moon, but this time we'll maybe do it sustainably. Scott Manley has a statement. Sorry, guys, I don't mean to get too wrapped up in this stuff. There's not a lot of stuff that I take seriously, but pushing the boundaries and exploring the final frontier is very high on my list of things to do. Because if we're not using that to occupy our time, guess what we will? We will fight each other, and we'll use that to occupy our time. I don't think that's smart. Go explore the frontier. Space is always trying to kill you at every single waking moment. Humans are perfect for that. We are designed for that. We're built for that stuff. We're built to overcome adversity. It's a human condition. People love it. You know, people always give these bullcrap arguments like, well, we need to fund NASA because humans are explorers. No. Our monkey brains are perfect for an environment that's constantly trying to kill us. You know why? Because we evolved over billions of years on this planet where everything was trying to kill us constantly. And if we don't have some type of existential threat or some type of thing to focus our tasks on, guess what? We consider each other that existential threat and we start fighting. Space is the perfect avenue to exploit the human condition. It's perfect.
Discovery, go at throttle up.
Arguably, we're designed to live on Earth. Yeah, you're right. So what is Scott saying on the subject? I'm going to bet that Scott somewhat agrees with what I'm saying. His explanation's probably a little bit nicer than mine. Let's hear what Scott has to say. Just listening to the Viper press conference and NASA say they're instead going to provide a mass simulator rather than an actual rover. It's so comical, I can only hope it's the result of some internal political ploy that backfired. I'll ask, is the Artemis program allowed to have that clear of a stated goal? Aqualex, that's up to the president. I'll be very candid since we're laying everything out on the table here. The last president had a very clear stated goal about what the Artemis program was supposed to accomplish, at least in the interim 4 years. That goal went out the window in 2020. And the entire integrated program, one last thing, the entire integrated program doesn't exist if you don't have a stated goal. You have to have a stated goal so you can set up your integrated architecture to solve that stated goal. If you don't have a stated goal with a deadline, the whole system slows down, and then the bureaucracies are just they're just vying for table scraps, because there's nothing to get the political winds to work for you in that regard. This is why I said the last president saying that 2024 is a stated goal for returning people to the moon was so ridiculously important, because that started to leverage the system in our favor. That made Jim's job a lot easier. And look what happened. All of a sudden, SLS started coming together. That's weird. It went from in 2017 to like, yeah, maybe we'll launch this in 2024, to the Artemis 1 mission that happened a lot faster. Look, stuff started actually getting done. The green run started getting done. Core stage integration started getting done. So did you notice that? Stuff started getting done. Wait, they're going to send a rocket to the moon with a mass simulator and nothing else? Geek, the Viper mission was part of the commercial lunar payload services. And the reason why I'm doing this is because it's painful to freaking say, but I'll say it because I like it. The Viper mission contracted Astrobotic out of Pittsburgh. You know Astrobotic, right? To build the Griffin lander, to land a bunch of scientific payloads, but the primary payload and what the lander was designed around was the Viper rover. Supply chain issues and cost overruns have basically put NASA in a position where they decided canceling the rover was a good idea, but not canceling the service for the commercial lunar payload service launch and lander is the best course of action forward. What does that mean in plain English? Rather than seeing the rover through because it's too expensive, whatever the hell that means, you know, they said we'll take all of Viper's equipment off and we'll put it on another rover that does the exact same thing. So they had two rovers that do the exact same thing with redundant capability. Yep, okay. Their best course of action is to take the rover, cancel the rover, put its parts on another rover that they're going to launch supposedly later this year, and then land Astrobotic's lander on the surface of the moon with a block of metal in place of the rover as a mass simulator. Can you see why I'm so pissed off? What is a mass simulator? A mass simulator is a fatal owl. It's just basically a brick that simulates the mass of the payload that should be on there. They use it for testing. So let's say we're playing Kerbal and I want a rocket that moves 20 tons into space. Does that mean I need to design a 20-ton satellite? No. Just put 20 tons of ore up in the top of the vehicle and test fly it, right? Mass simulators are usually used for configurable testing. Mass simulators are not used when you have your head so far up your tailpipe that you decide launching a block of metal on this rover to the moon is somehow going to be cheaper than the rover. I would like to add at this point in time, just for the record, not to speak like a lawyer, but just for the record that NASA sank $450 million into the Viper mission. So we're launching a $450 million block of metal to the surface of the moon. Do you see why I'm pissed off? Does that make sense? People are like, EJ, calm down. No. There's times where it's okay to get pissed off. Now, don't get me wrong. I'm usually good at keeping my cool. This is stupid. This is ridiculous. It's disgusting. Even if the cost was too much, et cetera, like even if the price tag was ridiculous, it's honestly at this point to me, I think this is a pretty vital component here, fellas. I think that, NASA, as an American, NASA is a feather in our cap. It's a point of national pride. This is gross. We said we're going to put a lander on it, and then we said, nah, it's too expensive. Never mind. And we put a block of metal instead. I'm ashamed. As an American, I'm ashamed. I'm ashamed. I thought the number one reason they're calling out Viper was that it because super delayed production-wise and they don't want to wait for its production schedule. Yeah, Killerbot, they don't want to wait for its production schedule because it could potentially take away costs from other commercial lunar payload service programs. And Killer, why? Why is that a viable reason? Oh, I don't want to wait. Yeah, I don't want to wait. Yeah, I don't want to wait an extra year. Was there a vote by Congress to nix this project? Nope, NASA decision. Because they have a schedule they're trying to maintain. Oh yeah? Where's this schedule that you're referring to? And I'm actually asking, what schedule are you trying to maintain? What schedule are we talking about here? And once again, I'm not being facetious. I'm not facetious. I'm not being a jerk. Facetious wasn't the right word. I'm not trying to be a jerk. If there's an integrated schedule that you know about that I don't know about that has clear, conclusive deadlines for lunar landings, human exploration, these robotic missions, please let me know, because I can't find one. Now, Killerbot, okay, let me be real. I'll be honest with you. I'm trying to be a little bit of a jerk, okay? Just a little bit. You can go search NASA and find a PDF that says what they are going to do over the course of the next couple years. You can find integrated mission architecture for NASA into the 2030s, okay? That means dick at this point. Every time NASA releases one of those integrated mission architecture charts that says we're going to launch and land people in this year, it gets pushed back. It's been getting pushed back for the last 10 years. I have, honestly, and this is going to sound pathetic, I have no faith in NASA in getting anything done on a reasonable timescale right now. There's no, I'm sorry, that goodwill went out the window a long time ago. You know what I'm saying? I get it. They have a schedule to keep. What schedule? Facetious is the right word? Oh, good. At least my brain isn't totally paced. Sorry, covering all this news, Fatal Owl, is making me dumber. I feel like I'm losing brain cells left and right. So if their pushbacks time-wise are frustrating, why are you also frustrated with them canceling a piece to avoid additional pushback? You're good. You're not a dig. It's a discussion. I'm trying to understand. No, you're asking good questions. Let me read that one more time. So if their pushbacks time-wise are frustrating, why are you also frustrated with them canceling a piece to avoid additional pushback? Killerbot, this is part of a trend that I've been seeing with NASA happening for some time. And I guess the right way to articulate this would be to say, how do I know that that's not going to happen with the thing that they're worried about this schedule encroaching on? How do I know? How do I know they're not going to cancel the Prime mission for the same exact reason? How do we know that? How do you know they're not going to do the same thing? I don't like Killerbot. I love NASA. NASA is what inspired me to do this, to teach people about space flight. I love them. But you got to be critical of things that you love. You can't just sit there and adore it all the time, right? If you really truly love something, you got to be honest you got to be honest, right? Like if you have a significant other, you got to be honest with your significant other, or I think that's disingenuous, right? I hate being critical of NASA. It really bothers me. Seriously, I don't like it because this is the inspiration that has given me so much joy in the past. Watching the shuttle assemble the space station, watching the Hubble servicing missions. I've seen what NASA can do, and to see this it bums me out, dude. This isn't what NASA should. Yeah, Aqualex, just space exploration is just fine for table scraps. Disgusting. Disgusting behavior. You don't need to post it 4 times, dude. I got it. Got it. I ask again, what can we do? Ethereal, what I'm doing is calling out this idiotic behavior when I see it. That's the only thing that I think will help, right? I have my solutions about how to fix this problem. However, am I going to be made NASA administrator? Come the next presidential election? Probably not. So the best thing that I can do is show people, look, this is stupid. This is really dumb. This is not how NASA should be working. Blue Origin tweet, testing landing legs. Cool, Pop. Yeah, Black Ops. Yeah. EJ, please. If I missed it while feeding my cat. What can we actually do anything about this situation? The best thing that you would be able to do with Ethereal is if you're a U.S. citizen, write your congressional representative. Send an email to your congressional representative if you really want to, saying that you need to give NASA more money. That's all. If you want to be really good, cite the specific programs. You have to write your representative. Your representatives are what pull the purse strings on this stuff. That's the best thing that we can do. Ethereal, I'm going to hate myself for saying this because you're inviting the whirlwind here. But look, NASA's stakeholder expectations, their stated goal, is controlled by the executive branch of the federal government of the United States. So, what that means is another way to do something about this is to pay attention what presidential candidates say about spaceflight. Pay attention to it. See if it's bullcrap. See if it's not. Take what you know about spaceflight and take what they're saying and see if it's possible. The best thing we can do is just crowdfund our own rocket and build it in our collective backyards and use drone to transport all the pieces to the same location in Mexico for final assembly. I don't think that's a good idea. You can do that if you want. I'm gonna sit that one out, okay? They must have an old test drone or something lying around so they can put it on so it's not a complete waste. Apparently they don't, Pure Tough. Or somebody at NASA's mission management office doesn't have the wherewithal to think of something like that. In which case, you need to get the hell out and put somebody in there that knows what they're doing. I'm not American, so I'm not really in the loop about this. What are they saying about that, actually? That's how NASA canceled a rover, a lunar rover, basically saying that it's taking too long for said lunar rover to, get developed. So they canceled the rover, but they didn't cancel the lander that the rover was going to land on. So we're going to send a lunar lander to the lunar surface with all the provisions to launch, to have a lunar rover on it, and not have a lunar rover on it. We're going to send a lunar rover lander to the moon with no lunar rover. Yeah, ethereal, that's what I mean about reaping the whirlwind with that statement. Yeah, single issue voting. I understand. I understand. I think you talked about the candidates, what they say about space exploration. No, Rem, I haven't said anything. That's up to you guys. You guys need to do that research. I'm sorry. I would love to be able to break down presidential candidates' plans for space exploration, but first of all, we haven't heard any. We haven't heard any from anything that's not the incumbent. Now, I'm not going to sit here and pretend like we don't have at least a glimpse into what incumbent spaceflight policy looks like. But once again, I'm not going to sit here and break it down, dudes. It's not worth it. It's not. All that's going to do is piss people off. Not worth it. Not worth my time. You guys, but I have to say that you guys have to go figure that out for yourselves. Hellfish, the big problem with James Webb was the mirror array that James Webb uses. When they proposed James Webb, that technology didn't exist. They thought it would have taken X amount of dollars to develop that technology, which, once again, I think is hilarious. Yeah, because you can predict the future. This is what I'm talking about. Said, oh, it'll probably take us about 5 years to develop the mirror technology for James Webb. Yeah, probably take about 5 years and about $1 billion. 20 years and $6 billion later, they had it developed. Snake oil, dude. Anytime somebody says, oh yeah, this shouldn't take very long, it's aerospace. Every project's going to take some time and take a little bit of cash. And see, here's the thing, Hellfish. It's not just one. It's just, I mean, Northrop Grumman built James Webb, but it's not just that. It's all the NASA and the NASA scientists that are associated with that program. If you encounter a production bottleneck like that, everybody else has to stand idle. Guess what? NASA's not going to stop paying them just because the satellite needs a little bit longer of a technology. It needs more technological development. This is what I mean about project management. Guys, this is why I said a little while ago that switching Europa Clipper to Falcon Heavy will end up being almost as expensive as SLS, despite having a lower launch cost. Nice, Forge. That's cool. The argument for mission architecture is so accurate that where Artemis is going to become Apollo 2.0. Matt, look, for the longest time, I was spoon-fed from anyone that had any useful experience with this that Apollo wasn't sustainable. All right? I see the word sustainability get thrown around. It's, not sustainable is basically code speak for I don't like this program and I don't want to fund it anymore. I don't trust anyone, NASA, anywhere, any aerospace company that says something's wrong. I don't trust it. It's bullshit. Neither should you. Anybody that sit here and says that Apollo is not sustainable is off their rocker. You know how I know? Say we can extrapolate what Artemis's mission goals are, right? Say we can. What's Artemis goals? We don't even know. NASA, I don't think NASA even knows. Anyway. Artemis's goals are to return people back to the moon, leverage the commercial market for science prospecting missions before you send people back to the moon. I should have said it that way. Establishing a lunar base and a lunar gateway to be able to learn and understand how to live in deep space for long periods of time, to set us up with the scientific knowledge and understanding that we need to start going to Mars, to start Martian architecture, to start figuring out the best ways to do it. Let's just say those are the stated goals. Is there anything in those stakeholder expectations that Saturn V can't do? Saturn V can get people to the moon. It can land people on the moon. That's 2 right off the bat. Saturn V's architecture could be used to build a moon base. That's 3, knocked off. Saturn V could be used to build a gateway. That's 4. Saturn V can basically do everything that SLS was designed to do better. So don't give me any horse crap about how Apollo wasn't sustainable. You could just do the Artemis program's goals with the Saturn V, and it would be able to do every single one of those goals better than SLS can. I don't believe it. Anytime someone says it's sustainable, that's just code speak for I don't like this program. So, dude, I've been told by a lot of people that work in the spaceflight industry, a lot of people that spend way more time reading about this stuff than I do, that Apollo really wasn't sustainable, and that's why we're doing the Artemis program. Unless I'm blatantly glossing over some glaring observation, and I don't think that I am, but I might. I'm not perfect, right? I think that's a load of bullcrap. Yep. Load of bullcrap. That's what I think that is. Why do people dislike the Apollo program? I don't get it. It did carry a heavy price tag, Rem. Of course. But that price tag was paid for with scientific knowledge. We learned a lot with the Apollo program. Also, there's that whole digital processor thing. The Apollo program was the first digital fly-by-wire aerospace vehicle ever designed, because that's what was needed to land something on the moon. We needed a computer-controlled system that interpolates inputs from a pilot and applies those inputs to the hardware. Something that almost every single airplane uses nowadays, or every single, well, not all of them. A Cessna doesn't have fly-by-wire, but a digital flight computer, every fighter plane uses that. Every fighter plane has that technology. Also, because we threw a lot of money at looking to pioneer digital miniaturization of digital processors, did anybody notice that the personal computer started coming along in the 70s after the Apollo program? Started getting personal computers. Some guys basically took what we learned from the Apollo program and started selling computers out of their garage in Palo Alto. You know? Dude, stuff like the Apollo program, people say it's too expensive. I can tend to say you wouldn't have this if it wasn't for the Apollo program. The Apollo program advanced miniaturization of digital processors by about 20 years. Easily by about 20 years. Look at what a computer looks like in 1962 and what a computer looks like in 1972. Those are two way different things, and that's entirely because of the Apollo program. Hell, yeah, cars have drive-by-wire. Sure, I would. Yeah, the processor in... See, everybody says, though, the processor in this is like a bajillion times more powerful than the processors that we use to land people on the moon. Two things about that. One, you don't need a lot of processing power to land on the moon. I know, because we did it with, like, a computer that basically runs on potato. Second of all, this wouldn't exist if it wasn't for the Apollo guidance system. Without the Apollo program, we wouldn't have Twitter or TikTok. Fatal Owl, when you say it like that, yeah, okay, maybe it was too expensive. Any more KSP today? Yeah, we'll get back to KSP. Sorry, I wasn't expecting to get blindsided by pure incompetency from NASA today, fellas. Sorry about that. It's a joke. Give me 1 second. Check the new Glenn tweet. Sure. Yeah, sorry guys. I didn't expect to get, blindsided by the dumb. NASA caught the dumb. Don't catch the dumb. Okay? Like, fellas, look, I grew up on the internet, guys. I was buried in a computer through middle school and high school, on the internet all the time. I got a pretty thick skin. If anything, people say like, oh, I've been bullied on the internet. Well, yeah, dude, don't get me wrong. That's messed up. You should treat people with respect, right? But also at the same time, go to any Call of Duty lobby and those rules get thrown out the window. What I'm trying to tell you is that I got a pretty damn thick skin. There's not a lot of things that piss me off. Seeing NASA, which should be a beacon of, like, our ability to be able to push the frontier. Seeing NASA basically get pulled down to earth, pun intended. I'm hanging with Sawyer too much, sorry. Seeing NASA get pulled down to earth and be susceptible to the same kind of bull crap that we encounter in real life, like with it just in day-to-day life, I'm sorry, it's infuriating. It's infuriating. It like, that triggers me pretty hard. Like, I just... I was about to say, what would Von Braun have said about this? Well, he would have gotten super freaking pissed off and probably left. Oh, wait, that's exactly what happened. When they said we're canceling the Apollo program, we're going to replace it with the shuttle, Von Braun took one look at the shuttle and said, that's the dumbest thing I've ever heard in my life. This is a very, very big mistake. That will cost us a capability that nobody else has, and we're throwing it out the window because of idiotic policy, frankly. Yeah. And then he promptly left NASA and said, F you guys, I'm out. Yeah. They said, hey, come work on the space shuttle. He said, yeah, I'll do that. I'll do that when I have a tag around my toe. Piss off. Go and read about it. It's just disappointing, dude. Like, I can't believe that. It's like seeing behind the scenes at Disney World. It ruins the illusion. Just ruins it. EJ, over here, happy news. Dude, I have the thing open. This is coming from Blue Origin here. We recently completed New Glenn's first stage test of its 6 landing legs, a key area for reusability, which lowers the cost of access to space. Do it, please. Landing gear stow inside the rocket during flight, deploying as the booster gently touches down on our landing vessel at sea. Hey, Smart Ship, how you doing? That's at Complex 36, which is pretty cool. Is it just me or does that look fragile? It's fine to me. Yeah, maybe that's not the best example, Hired. I was trying to think of something where it shatters the illusion. There are other analogies that I can think of, but I don't want to say them. Maybe it's realizing a fictional character doesn't exist in real life, but I don't want to go here and sit and say that, you know, which fictional character or which character is not real. You know what I mean? Because there are people watching with kids. Santa Claus and the Easter Bunny absolutely exist. Oh yeah, absolutely. How do you think he's going to deliver all the toys? Duh. Tooth Fairy also exists too. How'd you get that money under your pillow? Yeah, exactly, Pontiff. That's pretty cool, man. Oh, Hired, that's despicable. It's messed up, man. It pointed out to me that the government is just people, you know, like the people you come across on the highway. Yeah, those people. Aqualex, I understand what that analogy is supposed to be, but I can tend to say you encounter those people on the highway and you still get to your destination. That's on you to be able to navigate that obstacle, not them. They're just going to be morons. Your thoughts on how the Chinese space program is handled? Rustbox, I'll be 100% honest. Look, okay, there's good and bad with the Chinese space program. Vipers being canceled is a stupid loss. That's right, Sedated. Yes, it is. It's idiotic. The Chinese space program, they launch a lot. They're getting scientific exploration done. They built a space station all by themselves. No help from anybody except I appreciate their resolve in wanting to push the boundaries of scientific exploration and using it as a way to peddle influence. I appreciate that. I can appreciate that as an American. That's what we do. However, The Chinese are very laissez-faire on human life when it comes to spaceflight. I've seen horror pictures of guys with hazmat suits on handling nitrogen tetroxide. Hazmat is nowhere near good enough to be able to withstand NTO. NTO will leak through a hazmat suit. i.e., the guys that were handling this NTO with hazmat suits are probably dead. China doesn't care where their stages come down. They drop on populated areas with toxic propellants and they kill people. They don't say that they kill people, but then again, in Chernobyl, they said they didn't kill anybody either. Yet here we are. I like that they're pushing the forefront. I'm happy that somebody is doing it. I can't get behind it just because some of the blatant disregard for human life. Sorry, it's not space exploration if we just approach the problems like lemmings. Did you check my link from China's Cosmo Leap? I stepped away. Yeah, I've seen that before. I haven't checked it though. Maybe I shuffled the link around, dude. I have so many tabs. Oh, it was just linked again. I'm sorry. Look, there's a certain rule set here. The disregard for human life is just... Look, man, if you're willing to do that with people on the ground, how can I believe you that you're going to do that with the people up in space? And don't get me wrong, I'm not even like OSHA, safety standards. I'm pretty laissez-faire when it comes to that. Allowing your stages to go ballistic, spent stages on orbit, and careen out of control willingly, and then having stages from first stages come back down and land ballistic just wherever. That's not spaceflight, dude. Rockets that go up, come back down, and hurt people have another name. They're not called rockets. Those are called missiles. I don't do that. We don't do that here. Can't ethically get behind that. I'm sorry. I appreciate the pushing the scientific boundary, but not if human lives are the price tag. What is this? Oh, yeah, this. What, that wasn't loud enough for you guys? Thanks for the tinnitus. Oh, you're welcome. Here, with more balanced sound. Now, I mean, it's not going to matter. Your hearing's already lost anyway. That is it is a little loud now that in retrospect. Well, at least we know that China has really good 3D artists. Look, all I'm going to say is that spaceflight, human spaceflight, requires a certain mindset. So what does that mean? What's that mindset? What am I talking about? That mindset involves being able to improvise, adapt, and overcome. Now, what does that be? Okay, what are you getting at? All right, look, copying off your buddy's test, copying off your buddy's final exam is not going to make you, let me rephrase that. Copying off your buddy's final math exam is not going to make you a better mathematician. And if you're going to do a job that requires a lot of math, like spaceflight, you best not be copying anybody else's answers. That demonstrates a fundamental misunderstanding about the requirements from a systems engineering and development standpoint that is needed to push the boundaries of spaceflight. Let me be a little more candid here. China needs to come up with their own designs. If they can't come up with their own designs, they're just going to keep copying us, and they'll just play second fiddle to whatever we're doing because they can't come up with their own stuff. All they know how to do is copy people. And I'm not trying to be a jerk. Look, China has an insane industrial base. The best in the world. Maybe second to only the United States. Maybe. They make everything, dude. There's tons of heavy industry over there. Like an ungodly amount. There's entire cities that are just factories. It's honestly awe-inspiring. Like, I'm not trying to be a jerk about that just because I'm an American or something. There's clearly they can. I'm not saying there's stupid people over there, but if you're just going to keep running Falcon 9, you're not going to get anywhere. Spaceflight requires you to be able to improvise, adapt, and overcome. So unless your goals are exactly what your adversarial country is, you're not going to push the boundaries. And I think they know that, but also all I see is copies coming out of there. You need to have a certain mindset to go about engineering, to go about aerospace engineering. You just do. Can't be copying people. Now, don't get me wrong. There are designs, you can be influenced by a design. Sure, absolutely. Like von Braun's, the aggregate 4 rocket motor was heavily influenced by Robert Goddard's liquid fuel rocket engine. If you look at Goddard's liquid fuel rocket engine from 1922 and you look at the aggregate 4, is that a copy? No, it's influenced by the design. The United States and the Soviet Union all got access to the aggregate 4. Soviets had more hardware and we had the engineers. We got von Braun. But the Soviets got the factory, right? From what we learned from the aggregate 4, we didn't just make rockets that were all based off of this. The Redstone rocket, the rocket that NASA first used to move people past the Kármán line, or at least close to it, is derived from the aggregate 4. But does a Redstone rocket look like a A4? Look like the V2? It does not. We used what we learned about the aggregate 4 to push the envelope in this country. It's not just von Braun. The Atlas missile, first derived in 1954. Does the Atlas missile look anything like an aggregate 4? Does it use any mechanism that's even remotely close to the aggregate 4? No, but it was influenced by its design, sure. Elaboration is what's needed. Why do I bring up Atlas? Why do I bring up Redstone? Atlas was influenced by the aggregate 4, by von Braun's V2 weapon. I call it the aggregate 4. That's what von Braun called it. I don't call it what Hitler called it because Hitler's an idiot. I think that's pretty reasonable. The aggregate 4 was influenced by, or the Atlas missile was influenced. The SM-65 Atlas missile was influenced by what we learned from the aggregate 4. It's not a copy. The Redstone missile is a copy and an expansion of the aggregate 4. The Atlas missile put John Glenn into orbit with a Mercury capsule. The Redstone rocket put Alan Shepard into a high suborbital trajectory. See what I mean? The Redstone is almost a direct copy. Almost the same engine and everything. The Atlas is not. You need to be able to elaborate on the design. You can't just copy it and be like, yep, cool. That's elaboration is what shows engineering prowess, especially when it comes to spaceflight. Another good example here. The Soviet side of things. Sergei Korolev got the aggregate 4, and they honestly said, figure this out so you can make missiles, or we'll shoot you. He said, all right, fine. He made the R3, the R5, and the R7. The R3 is a direct copy. The R5 is an elaboration, somewhat analogous to a Redstone missile, ironically. The R7, the Semyorka, that is elaboration. That is not an improvement, but the ability to use what you learned from the A4 to build a rocket that is specifically suited for what you're trying to accomplish. That elaboration is needed because your goals aren't going to be the same as everybody else. That elaboration got us the Atlas missile, balloon tanks, stainless steel upper stages, got us Centaur, got us the RL-10, the F1 engine, the J2. Elaboration is required if you want to push the boundary. It's absolutely needed if you're going to dare mighty things. Do you see any of that coming out of Chinese aerospace program? There is some, but it's not a lot. By and large, it's mostly copied Soviet hardware and copies of a lot of NASA stuff, because NASA stuff is open source for the most part, certain things. You're not seeing that elaboration. But here's the thing. Here's another poignant thought. You're not seeing that elaboration yet. And that's what I mean. Their space program is very tenacious. They're making advancements pretty rapidly. I'm pretty sure we're going to get to a time where China doesn't need to copy anybody. They're going to get to that point, I'm pretty sure, and I wish them the best in their peaceful endeavors. Abso-freaking-lutely. All right, at least someone's going to do it, because we're going to be launching landers that are specifically designed to land rovers on another planet, and then we're going to deem it too costly. We're going to deem it, it doesn't jive with our scheduling risk, and we're going to deem it cheaper to send it without anything than sending it with a rover. Okay. Wuran is not a copy of the shuttle, but it's an improvement. No, it's not, though. Keep hitting that copia. It's not. Even the Soviets admitted it's a copy. Energia is an improvement. That is arguably a way better lifter. That's arguably one of the best super heavy launch lifters ever developed. Ever. Right on par with the Saturn V. The only reason why it didn't get to do anything is because the Soviet Union collapsed. Is engineering prowess the goal? I'm not following the logic. Elaboration is needed to go further in space, Uranus. That's what I'm trying to say. Is it elaboration or iteration? I just want to make sure I understand. Elaboration feeds iteration, Spiffy. You have to have that mindset that you're going to improve this design. You're going to make it better. You're not just going to copy. The iteration comes from said need to elaborate. That's what I'm elaborating on. It's a mentality thing. That's correct, Leafy. See, okay, that makes sense, right? And once again, all I see is China copying things. And my guess is that they're doing that so they can understand, so maybe they can elaborate down the road. But their space program has been going for a pretty good while now. I still don't see any any homogeneous stuff. All of this stuff is derived from post-Soviet, Russian, and copied industrial espionage from the United States. I don't see any elaboration. You don't see something like the R7, an advancement like the R7 coming out of it. Everything is just a copy. Now, like I said, and that's not to say that they won't get there eventually. I think they will. I think that mentality is much more difficult when you don't have it to begin with. You know what I mean? How similar are NASA spacesuits to the Chinese? The Chinese spacesuits are a combination. The Chinese lifted the best components off of the Russian Orlan spacesuit and the best components off of NASA's extravehicular mobility unit. They took bits and pieces, they copied bits and pieces off of each suit that I liked, and they made one that's kind of halfway in between. Yeah, Lafaloop, maybe. Pure Tough Region rocks. The best thing ever said. Some people's young moon landing was real because the Russians said we did. That's right, Pure Tough. I love watching moon landing deniers' brain short circuit. When I say that, that's my favorite thing to do. But we didn't go to the moon. Soviet Union said we did. Oh, was that a cover-up too? Oh, we fooled them. Yeah, okay. We fooled the country that launched the first person into space, the first artificial satellite into space. Yeah, we fooled them. Okay, first EVA. We fooled them? Sure. Okay. It's all lizard people, come on. Yeah. Yeah, first Venusian lander, the only thing to ever transmit a signal off the surface of Venus. We fooled them. Yeah, it's a great conspiracy theory, right? Sure. Yeah, I love saying that to moon landing designers. They got no answer. Their only answer is that, oh, we fooled them too. Okay. That's when I usually just stop the conversation. Just go, yeah, man, you're right. You're probably right. Sorry, guys. I'm in a super pissy mood today. That stuff with NASA just really pissed me off. Like, I'm sorry. I don't mean to be such a cynical piece of shit on here. My bad. I'm usually not like this, but NASA's really making my job difficult today, man. They're really making my job difficult. Now, Matt, see, here's the thing. I've told that to people, and I've changed a couple of people's minds. They say, oh, yeah, that makes a lot of sense. So I'm not going to stop doing it, but yeah, you gotta, I guess it comes down to having the wherewithal to see if somebody wants to argue, because people love arguing. Believe me, I'm Italian. We love arguing. And people that want to learn. You gotta find the difference. I like to think that I have a lot of experience with being able to figure that one out by this thing that's over there. See that chat thing that's over there? Yeah, oh yeah. Reading that for a decade straight, it's pretty easy to spot. You know? How about we make our own space program that's not managed by idiots? Fun fact, Rem. Elon Musk came to that conclusion 22 years ago. What did NASA do today? Uranus, NASA canceled a lunar prospecting rover because it took too long to make, but didn't cancel the lander for said rover. So we're going to launch a lander to the moon that's designed to carry a prospecting rover. I don't know. The lander got delayed a little bit too, because sometimes this stuff takes time. You want to push the boundaries going back to, we haven't gone back to the moon in 50 years. We have to relearn how to do it. So there's going to be some there's going to be some adversity here, right? Stuff's going to take time, right? So the lander is going to launch late to the moon with other scientific payloads on it, with basically an empty parking space on the top of it where the lander should be. NASA is going to launch a lunar lander that's designed for a rover with no rover on it. Do you think the Clipper spacecraft will be done until the transfer window? Bajor, I have a whole thing about Europa Clipper that I have a lot of thoughts about the Europa Clipper mission. From a scientific standpoint, it's an awesome mission. Bajor, all I'm going to say is I hope so. I meant KSP, but you're right as well. Yeah. So NASA invested $450 million into that rover. So NASA invested $450 million to launch a block of metal to the surface of the moon. They're going to put a mass simulator, basically a piñata of the actual rover that's the same weight or mass as the rover, to make sure that the lander that's designed to land the rover operates correctly, because the lander was engineered around landing the rover on the moon, not landing nothing on the moon. Can you elaborate on your points of apprehension about the Clipper program? Okay. The Clipper program is a symptom of the same exact problems. So, 2018, a representative from Texas named John Culbertson, crossed party lines to get the Europa Clipper mission, a mission to go to Europa and land on it, funded so we could push the boundaries. The rover and the lander were going to be engineered in California by JPL, which they are, or the probe, I guess, not the lander and the rover. Sorry, I'm talking about Viper. The probe and the lander were going to be made by JPL in California, and they were going to launch on SLS. That's the reason why John Culbertson did it. He started working on it in 2017 into 2018. And he got primaried in 2018. I forget. I think Bernice Johnson or something replaced him. I forget who replaced him. He got primaried. Whatever. The will of the people. I get it. So what he wasn't finished doing when somebody else got elected to his position was procuring a launch vehicle for Europa Clipper. So they basically got the contracts to make the probe, but him being from Texas, he obviously wanted to use SLS, right? NASA's lifter, so Johnson Space Center would have something to do with it, right? You know, mission control and all that. So Europa Clipper went on, and the person that replaced John Culbertson didn't care. So the development of Europa Clipper went on basically with the plans of launching on SLS, but nobody ever bothered to tell the SLS program or any of the SLS people. So fast forward to a couple of years ago. Somebody starts connecting the dots. Wait a minute. This thing's supposed to launch on SLS. It's supposed to launch on SLS. There's no SLS rocket allocated for this mission. That, and there were a couple of other things with potential vibration vibrations from SLS. SLS is a little bit of a rough ride for sensitive payloads that are going for scientific payloads going to other planets. The vibrations from the SRBs, I don't think an acoustic problem is something that couldn't be solved, for what it's worth. A lot of people know about the vibration problems and say, well, it can't launch on SLS, the vibrations are too great. Those type of people are the same reason why Viper is launching, the Viper lander is launching with no rover on it. Oh, they can't land on the rover, they didn't get it done in time. Ridiculous. That's a load of horse patootie, all right? So patootie. So 2022 comes around, they realize they don't have a launch vehicle procured for this payload that they've been working on for the past couple of years, and say, oh, let's just switch it to Falcon Heavy. Yeah, let's just switch it to Falcon Heavy. It'll be cheaper. Now, I know what you're thinking. Yeah, okay, yeah, Falcon Heavy is going to be way cheaper than SLS. But here's the thing. The launch will be cheaper. The mission is not going to be cheaper. I can say this with pretty reasonable conviction. The mission is not going to be cheaper. You pushed on cost. Because at the end of the day, it's always going to cost whatever amount, we don't know, because I mean, we don't know until we go do it. It's going to cost whatever amount to get to Europa, and we won't know until we actually do that, right? So if the cost is unknown, saying that you're saving money by launching on Falcon Heavy is kind of absurd, don't you think? That was the whole reason that NASA did it. That, and they wanted to get launched on some reasonable scale because somebody forgot to procure the launch vehicle. That's probably important for your space probe. Now you have to go about re-engineering your payload. Do you know why? SLS is not Falcon Heavy. Falcon Heavy might be cheaper, but Falcon Heavy has way less delta V than SLS does. Way less delta V. I don't care what anybody says. You could say Falcon Heavy is a better vehicle. You could say it's cheaper. All those things would be right. SLS has way more delta V. Now, why does that matter? That matters because your operational mission time frame just went from 5 years to 15. Meaning, because Falcon Heavy doesn't have the characteristic energy of SLS, nor the delta V that SLS has, that launching it on Falcon Heavy will save you money for the launch cost, but that cost gets pushed to a higher operational lifespan. Operations, per NASA Systems Engineering Handbook, operations account for 50% of your total expected life cycle of the program. Meaning Europa Clipper was engineered to work probably 5 to 6 years, right? Some of that would be coasting on SLS, right? And then after that, you're playing with house money, right? Like what Curiosity and Perseverance are. And even Ingenuity. They're working well beyond their life cycles, right? But that's playing with house money, right? Meaning it got there, it conducted the science you wanted, and anything else is just a bonus. Now, think about Europa Clipper. 50% operational costs. So operations is basically everything that it takes to get the payload to the launch pad, launching it, and then having it go wherever it needs to go, and then conducting the science, right? That operational life cycle just tripled. Just tripled. You tripled it. How do you know that that payload will be able to coast? The payload that was with a baseline expectation of lasting, I don't know, let's say 6 years, is now going to be coasting to the destination for 8, and then operational after that for God knows how long, right? Anybody here that cites that we're saving money by launching it on Europa Clipper is crazy. We're not. We just push the cost to operations. Because guess what? All the scientists that work on this payload aren't just going to be out of a job while the payload is coasting. That's not how NASA employment works. Okay? Just because there wasn't any Apollo missions flying doesn't mean that Gene Kranz was laid off because a Saturn V wasn't launching, right? Gene Kranz is a flight controller for NASA. That would be absurd. That would be ridiculous. So now you're paying these people for an extra decade. That's an extra decade of salaries for scientists that live in Pasadena, California. California is a pretty high cost of living. Arguably higher than whatever our mean average is for this country. So that's a lot of money down the drain. And now, here's the crazy part. I'm not saying we shouldn't. This is emblematic of a much bigger problem. The same problem that Viper is facing. That there's no, like, okay, maybe we'll do this. No, we'll launch on this. Oh, I forgot to procure the launch vehicle. Oh, we'll launch it on this and we'll save money doing that. No, you won't. That's bullcrap. Just a tad higher, Spiffy, right? You're going to keep that mission team employed for another decade, at the very least. And now you have to start making changes to your spacecraft. Spacecraft has to be able to last that long. The spacecraft wasn't even... If you use whatever they baselined your Roper Clipper with, right? If you use whatever they baselined your Roper Clipper with, that's not even enough to do the coast from Falcon Heavy. Now, here's the thing. I'm not going to sugarcoat it. I will always argue for NASA to have more money. I don't really care where it goes as long as we get something done. Because of that whole cost thing that I was telling you about. You don't know how much that's going to cost until you go and do it. You have to have some baseline. I contend to say that launching this thing on Falcon Heavy is not going to save you money. It's not going to save you money. In the long term, it might shift the costs over a longer period of time, which may have the appearance of saving money. But it's not going to save you money. Even with the amount of money that they... I can tend to say that it would be even more expensive than if they had, just probably done their work right and actually procured an SLS for this thing. I can tend to say even launching with SLS and its high price tag, that probably still is going to be more expensive. Actually, I know it is. Actually, I don't know that. That's NASA's Systems Engineering Handbook. NASA says that, not me. Now, here's the thing. So what's the solution, Jay? Should we not launch Europa Clipper just because we're going to end up paying way more money for it? No. I said I don't mind with NASA having more money as long as something gets done. The reason why they switched to Falcon Heavy, even though they billed it as saving money by using Falcon Heavy over anything else, the main reason why NASA did it is because if they had waited around and waited for a launch vehicle, Europa Clipper wouldn't be launching for probably the next 10 years. So at the end of the day, you get the science pretty much at the same time if they had waited for an SLS. So they opted for a longer coast period. Out of the two options there, getting the funding for an SLS core, procuring an SLS core, putting the payload on the SLS core, and then launching it. I mean, you got to remember there's a launch window. There's a launch window, time sensitive here. Right? It's time sensitive. There wouldn't have been an SLS ready in time, any semblance of time that would be expedient in getting that science done. So NASA opted to they're basically going to end up eating the operational cost over time. Remember. So at the time, they did bill it as saving money on they did bill it as saving money on Falcon Heavy by launching on Falcon Heavy, and that's true. But that is because at the time, trying to go through with launching on an SLS, basically the payload would have never launched. So that's what they did. Now, I know what people are going to say. So, okay, what's the point here? NASA did what they needed to do and they made the adjustment. The reason why I bring this up is because compared to if you just did your homework right the first time, you just procured the launch vehicle, and we didn't because John Culbertson didn't take into account political winds, which is what I have to. And it's not just him. It's the entirety of NASA. NASA went basically 4 years before they realized they needed a launch vehicle for this payload that they're making. The reason why I bring it up is because if you had just done your homework the first time and procured an SLS core, and if anybody at NASA had the wherewithal to put 2 and 2 together, you would have ended up saving money. The reason why Europa Clipper is going to end up costing way more money than it ever would have in the first place if we'd just done it right the first time is because, and this is I'm basically parroting NASA Systems Engineering handbook again. The further there's a critical point in spaceflight development called a CDR, a critical design review. Okay? Critical design review is basically when all the blueprints are done for the vehicle. That's the point at which you move to manufacturing the vehicle. You start to get it done. Up until that point, when you're drawing up the plans or the blueprints for said vehicle, it's pretty easy to change stuff. And that's the reason why between preliminary design review, which establishes what the thing is going to do, and critical design review, which basically finalizes your design, PDR is a first draft, CDR is your final draft, right? That time in between there is the time to change the vehicle's stakeholder expectations if you need to. Oh, we're going to launch this on this launch vehicle. We're going to launch this on this launch vehicle. This is going to have a 5-year coast. This is going to have a 15-year coast. That would be the time you iron this information out. Once you get past critical design review, that's a commit point. It's point of no return. Not necessarily point of no return. You can move back to CDR. But the further you get into manufacturing, procurement of materials, procurement of funding, all the way up into operations, so basically when the payload launches, the further away you get from that CDR, the reason why I'm drawing like a logarithmic line here is because costs will logarithmically balloon the further away you get from a CDR and then decide to change things. They'll balloon exponentially. The further you are away from your critical design review, the more expensive it's going to be to change any stakeholder expectations on your spacecraft. I don't know, launching on a different launch vehicle. Hey, so Spartan, 55-month resub. See what I'm talking about? How about, if we design this vehicle with a 5-year operational cycle from launch to end of mission, or at least end of the stakeholder expectations for scientific understanding, right? Basically, we want to learn about, say this Europa Clipper is trying to learn about Europa's atmosphere, and we send it and it learns about Europa's atmosphere. Boom. You completed your goal. Does that mean you don't have an atmospheric sensing probe floating around Europa? No, I'm sure there's other science that could be learned there. Absolutely. Maybe biomes, observation. There's other things that you can do. And then you're playing with house money. There's no problem changing the spacecraft's goals after you complete your first goal. But in that time period between critical design review all the way through manufacturing, development, integration, launch, moving into operations from there to end of life, right? The more you change in between that stakeholder expectation completed and CDR, anywhere in that window, the more you change, costs balloon exponentially the further you are away from CDR.
I'm gonna run
Hey, Bree.
to the store and get your stuff.
Okay. Oh, Titan's here, buddy. All right, cool. How long are you gonna be? All right, cool. Just wondering. I got the dog now. So let me just finish this thought and then we'll talk about the puppers. So with Europa Clipper, and once again, this isn't my opinion on things. This is NASA's rule book for systems engineering. NASA says this is an idiotic thing to do. Changing your launch vehicle, changing mission operational life cycle, and changing the stakeholder expectations because of it. Also, they cut the lander out of the program. It's just a probe now. So they've changed 3 big stakeholder expectations. Costs are going to balloon because of it, because now you changed a bunch of things after the spacecraft was engineered. Europa Clipper is like 90% finished when they decided to switch it to another launch vehicle. It's going to cost us. And now, once again, NASA did that. NASA did that because they couldn't have been bothered at the time with doing their due diligence the first time. This is what I mean. That is my problem with Europa Clipper. Not the decisions that NASA made to launch it on Falcon Heavy. That's not a thing, right? I understand they did what they had to do, and they violated many of their stakeholder expectation rules, because what's the solution? Don't launch it? I understand why they did that, but once again, that is symptomatic of a much bigger problem. The bigger problem is that there's no integrated architecture here. Yeah, Alex, good luck getting that done. That's why nobody's done it. You have to have a lot, like, let's talk in Hearts of Iron points. To do what you just said, basically trying to give NASA a good foundation to stand on right now, you'd need thousands of political points to do that. You'd need a big PP to do that. Thank you for the insight. I'm sure it's been mentioned, so apologies if it has, but your audio seems to be low bit rate. Was the same the other day, not sure why, pretty sure it's not on your end. My audio is low bit rate. I don't know what that means, Pedro. There's no audio bit rate for me to adjust at all. Something is clipping when you talk loud. Oh, it's the fan, guys. Pedro, it's the fan. I have a fan blowing into the mic because that's the temperature in here right now. It's playing havoc with the microphone compressor. I need a fan blowing on me, or else I will die. What's that? "86 degrees. It's a problem that I'm working on solving, guys. I just need some capital to get it done. Long story short, I have a 10,000 BTU air conditioner in here, and it's not enough to flux the heat. The heat given from the computers plus ambient temperature, we're in a nasty heat wave in Massachusetts. The air conditioner can't keep up. It can't exchange the heat fast enough. That's nothing. Suck it up, yeah. Don't get me wrong, it's far from me. I was complaining about it the other day, but it's whatever. It is what it is. I'll figure it out. Yeah, that's the popping that you hear from the mic. It's the wind noise of the fan blowing on it. We're gonna have to fix that at some point. You're telling me, dude. Guys, the reason why I've been wearing dark shirts so much is because if I don't, I'll have pit stains. It's disgusting. Like, you'll be able to see it. Like, this shirt isn't actually... See what I'm talking about? I'm sweating my balls off in here, dude. I can't not have that fan blowing on me, man. Oh, shoot. Better insulation for the office walls. That's actually not the problem. Problem is that I have too much insulation and I don't have enough air movement around. I have a metal building that's insulated. Even in my office, I did all the insulation. I got like R48 roof insulation and R18 in the walls. Keeps you really warm in the middle of winter. Keeps you really, really warm in the middle of summer. Without any air circulation or any climate control systems inside of the garage, all the insulation does is keep the heat inside, like what it's supposed to do in the cold. That basically turns my entire office into a gigantic convection oven. It gets absurdly hot in here. And all that because you have stagnant air, the heat, it saturates the air with heat and humidity in this case. My little air conditioner isn't enough. It isn't enough. Now, don't get me wrong, the air conditioner isn't trying to air condition the entire office. But I don't have insulation between my office and the garage, so all that heat's just coming right through and the AC can't keep up. Windows, I work in a metal building. This is a metal garage. Yeah, it's just a straight thermo problem there. But yeah, anyway, Hassad, yeah, can't get rid of the Florida. Yeah, hopefully that helps. Yeah, this Viper mission brought up a lot of feelings, dude. It brought up a lot of feelings. This behavior, it's just so typical, dude. I'm so sick of it. Like, how much did NASA save by switching from SLS to Falcon Heavy? Nothing, Methuselah. They're going to spend more money on Falcon Heavy because they tripled the operational life cycle of their rover, of the Europa Clipper mission. They tripled it. So you're going to have that now that you have to go around and change a bunch of things on the spacecraft, on a spacecraft that's already built, that was built and designed for SLS. Now, don't get me wrong. NASA said they did it as cost. They did it because it's going to end up saving us a lot of money. It's going to save you money right now. Total costs involved in the mission. I'm making up numbers, right? Let's just say that if they launched it on SLS, yes, there's a bigger upfront cost. Sure, absolutely. Say it would have cost $5 billion over the course of the mission. The mission would have lasted, I don't know, 10 years. Launching on Falcon Heavy, because Falcon Heavy doesn't have the delta V that SLS has, makes it so the probe is going to be coasting for an exponentially longer period of time. So now your 10-year mission is now 15, 20 years. See what I'm talking about? It's going to end up costing the same amount. It's just going to be over time. That cost is going to be spread. I can tend to say it'll be more, and it'll be spread over a longer period of time. The real reason why NASA did it is because if they had waited for SLS, the thing wouldn't have launched at all. Not for at least another decade. Bill Weber is no longer serving as CEO at Firefly. Golden career. Hey, sorry for bothering you. Don't worry about it. Except for that. No soliciting, please. Golden, I'm just going to time that one out. But don't solicit anything in my chat, please. I'm not interested. If I am interested, I'll call you. Wasn't it also time? Yes. Okay. NASA, now don't get me wrong. NASA did the right move for the time. But citing cost as the reason is idiotic. It's not cost. It's going to end up costing way more. Because you just tripled the operational cycle of your mission. The alternative to that is it not launching at all. That's fair. That's fair. If they sat there waiting around for an SLS, it's going to take a year, decades. It's going to take a long time. The point that I'm trying to make is that if NASA had just done their due diligence in the first place, they designed the problem here, the big problem that... Oh, Titan knocked over my keyboard. You okay, buddy? You're a good boy. How you doing? The doggo is here, guys. Hi. Hey, buddy. I'll bring up the doggo cam a little bit later.
Discovery, go at throttle up.
The problem that I'm trying to shine a light on here is that if you look, you designed this payload to launch on SLS. You weren't entirely sure if it could, because you designed it around a launch vehicle that frankly was not operational at the time, which thing one, red flag number one. Two, you didn't bother to go and procure said launch vehicle. So they said, yeah, we're designing this payload for SLS. And the SLS guys are going, wait, you're doing what? The problem that I'm trying to shine a light on here isn't necessarily cost. I I think it's a matter-of-factly thing to say that if they had just done their homework right, if they'd done it right the first time and gone to procure an SLS and paid the extra money for that core and paid SLS's seemingly high launch cost, they probably would have ended up saving money. That probably would have cost less than designing it for SLS, going, sorry, never mind, Falcon Heavy, and then tripling the operational lifetime of the mission. The point that I'm trying to make is that if you just did it right the first time, this wouldn't have been a problem. SLS would have ended up being a cheaper solution than trying to cover up the mistakes, the glaring freaking mistakes. My problem is that they pitched this as, oh, we're going to save a lot of money by Falcon Heavy. We're going to save so much money by launching it on Falcon Heavy. No, you are not. You are not going to do that. If you'd done it right the first time, you wouldn't have to have saved money. It would have been just cheaper. That's the problem that I'm trying to get at. This just seems to be emblematic of NASA. This just seems to be par for the course. Let's contract out a rover to go prospect around on the moon. And let's pay a company for the lander. Oh, it's taking a little bit longer. No, let's cancel the rover, but honor the contract to launch the lander, even though we canceled the lander, and now we'll just launch an empty lander to the moon with no rover. We don't need to do that mission, and don't worry about it. We have another ice prospecting rover that we're going to launch sooner rather than later. See what I'm talking about? Dude, this behavior, like, guys, I didn't mean to turn this into a 6-hour rant about how NASA can't manage a project anymore. They can. They can. I'm just seeing this pattern pop up even more all the freaking time, dude. Hey, Elder Buffalo, 15-month resub. Not sure what a leadership. Yeah, King, I'll be 100% real with you. I discussed this a little bit earlier. I'm just going to get down to the gist of this. Forgive me for being candid, and I might sound like a complete douchebag here. Blaming politicians for NASA's shortcomings is blaming a problem on a boogeyman that is not quantifiable. We know the political winds can change. We know that happens. The fact that they don't take this into account is hilarious to me. You don't learn. You don't learn from your mistake. See what I mean? Blaming politicians at this point, you could. You're blaming it on a boogeyman that doesn't exist, unless you can give me some names with some conclusive evidence to back it up. Look, man, politicians just control the purse strings. That's all. Right? And I know what people are going to say. Oh, well, they control the purse strings. They're never going to give you the money for your project. Well, yeah, of course. If you just go in there and ask for $100 billion for a new lunar launch vehicle, yeah, of course, they're going to tell you to pound sand. What's in it for them? The point that I'm getting at here is that, look, you can't just sit here and blame bureaucracy and politics to make up for the fact that NASA isn't doing their job. Can't do that. Because there's clearly a way to get this to work. There's clearly a way. SLS, believe it or not, ironically, is a good case in point. SLS is one of the most sustainable NASA programs ever devised. So clearly there's a way to leverage this. There's clearly a way to use the bureaucracy and politics to make a program that is unkillable. A program that should never be susceptible to any type of cancellation. It's clearly a way to do it. Right? I can give you another example. You could make the argument that SLS has done diddly squat in the last 15 years. If you want to make that argument, you could, but I would raise you the Apollo program. What was that? What was that? Most expensive NASA program ever. What was that? Was that not dude, look, there's as much political divisiveness now as there was during the 1960s. During the 1960s, there's arguably more because we were involved in an idiotic proxy. Not going to finish that thought. Look, man, there's clearly a way to take that into account and make it work. NASA is not doing that. That's where my problem is. There's clearly a way to make this system work. We just don't. And the only thing I can really default to is either A, inexperience, or B, they don't care, which once again is chasing that damn boogeyman that I'm talking to you about. I gotta go off the premise that they at least remotely give a frick. Yeah, I stopped that thought real quick, weather guy. I'm like, nope, bad example. Bad example. How would you say SLS has done nothing in 15 years? I didn't say that, FaZe. I said you could make that argument. I don't think so. I think SLS has its shortcomings, but
Discovery, go and
SLS has its shortcomings, but that has to do with budget constraints. But we traded. That's another story. I think that, SLS is just buzzing along just fine. The only time that we've seen any increase or flux in the schedule where we actually saw some accomplishment is when somebody decided to hold them accountable and leverage the system to work for you. Jim. The only time we ever saw that is when Bridenstine held their feet to the fire. Why are we putting this rocket together vertically? Why did we spend billions of dollars to put this SLS core vertically when we could just do it horizontally? Can we do this horizontally? Yes, you can? Oh, you have an empty hangar over there? Good. Put it together horizontally over there. So, FaZe, once again, you don't fall into that trap. You can't just say, oh, it's bureaucracy or politics. That's chasing a boogeyman that's not quantifiable. You're going to be grasping, you're going to go insane that way. That's an inherently cynical way of thinking. There has to be a way to make it work. I refuse to believe that there isn't. But yet we see it. Do you think NASA's gears will start turning more when China lunar orbits an unmanned capsule? It's possible, Driados. Most maybe politicians are thinking why giving NASA more money? Why give NASA more money when Elon will figure it out with no cost from us? Pure tough. That, for the interim, is not a bad way of thinking. That's another problem I have with NASA's incessant hard-on to commercialize every single freaking thing that they can't get the funding for. But once again, that's another can of worms. We'll talk about that some other time. I think that's a good idea in the interim. SpaceX clearly gets stuff done faster. But if every time NASA encounters some budgeting problems, right, and says, oh, this program is behind schedule, or this program is a little bit over budget, let's just give it to commercial. Let's just give it to commercial. We're being savvy here. This is great. Every time that happens, is NASA basically turning over a capability I lost my train of thought. Damn it. I'm starting to get tired. Long story short, it's NASA pawning off our national spaceflight expertise to the highest bidder. We once had the technical capability of being able to put a man on the surface of the moon. That was a feather in our cap as taxpayers. Selling off that technology might be a good idea in the short term. In fact, I would contend to say that that's a great idea once the technology is matured and there's a market for it. That's what NASA's supposed to do. A good example would be what NASA is doing right now with Commercial Crew. Great idea. NASA has been launching stuff into low Earth orbit since 1962. It's about time you hand it over to the commercial markets and let that industry flourish. right? However, an unexplored avenue. I would contend to say that the moon is very unexplored. We've only gone there 6 times. There's no way we learned everything about that planet. Like, after the Apollo program, they said, oh, we've been to the moon already. We don't need to go back there. And then we found water ice on it in 2009, and, well, that changed. That changed real quick. Or quick enough, I guess. Well, Lunar Reconnaissance Orbiter was a little bit later for discovering water ice, but that's another story. Now, with all that being said, NASA trying to, let's just give it to commercial. They'll get it done quicker. They'll get it done quicker. The gist of what I'm getting at is that, do you want a corporation, even a corporation that we trust, SpaceX, for instance, do you want them being the only way to get to the surface of the moon? I don't think that's a good idea. I don't want a corporation capitalizing on the only transportation avenue to another celestial body. That sounds like Weyland-Yutani. That sounds like Altera. Yeah, pick your sci-fi. That'd be a monopoly, right? On a good note, EJ, your explanations are excellent, and we all appreciate it. Thanks, man. East India Company would be a great example, King. Great. Dutch East India Company, the British East India Company. Do you want corporations being the only viable method of transportation to a potential colony? I think that is a very stupid idea. And we can think of several cases in history, and also sci-fi. I was doing the sci-fi thing, but your reference is much better than mine. I'm not saying that SpaceX could do that, but that sets up the precedent for corporations to own transportation avenues in the future. I don't think that's smart. That's not a good idea at all. NASA needs to have parity. If SpaceX can land a man on the moon, NASA needs to have their own operated, okay, very important. They need to have their own operational capability of being able to do that. Now, right now, looking at it, that means SLS needs to exist. Absolutely. I don't want a corporation being the only way to get to the moon. Just look, when Artemis 3 comes around and those NASA astronauts dock to Starship HLS and they land with Starship HLS, that's awesome. You could make the argument that says, oh, well, they need SLS to get astronauts out there. But if Elon can put a 300, well, not 300, let's say 150-ton lunar lander in lunar orbit and then land it on the moon, you could be dang sure that they have the capability of getting people there somehow. If not, they're really close to it. Once again, I'm not saying this to badmouth SpaceX. I think this is the best avenue forward. Because history has shown what happens when a government only has access to the moon. Nothing happens. Go figure. But if we allow the pendulum to sway too far in the other direction, you get the East India Trading Company. And don't think, oh, it's spaceflight, EJ. Everybody's cool. That won't happen. You think so? Don't underestimate human nature. That's very naive. Yeah, Talon. This seems like the skill set for the rest of NASA isn't really up to par for new spaceflight things. Yeah, Talon, it's almost like we had a program that was going to reteach us that and reteach us how to go back to the moon that was really healthy and robust and probably the simplest way to get it done. And then we decided that program was too expensive. And then NASA promptly had a brain drain, and anybody that was anywhere remotely useful for anything that had to do with human spaceflight either got fired or reassigned to something else. Don't underestimate human nature. They're one of the bands of all time, man. I'm telling you. The repercussions from canceling the Constellation program did bring us some good things, like SpaceX. you could, but see, I think that argument is flawed in itself. SpaceX was happening already. SpaceX was part of the Constellation program. They billed it as, you know, canceling the Constellation program because it's too expensive, and the commercial market can do it for cheaper. What they actually did was just neuter the Constellation program and kept the parts that they liked, like Orion, like a shuttle-derived launch vehicle. Actually, the shuttle-derived launch vehicle is a little bit of a different story. There's a little bit of a different thing behind that. They just kept the parts that they like. The Constellation program is what saved SpaceX, because part of the Constellation program was turning over low Earth orbit to commercial partners and building a low Earth orbit economy, which, well, that actually happened. That part actually happened. Constellation had issues. Yeah, but Matt, the point, you're right, but the point I've been making this entire time is that if you're going to dare mighty things, you're going to run into issues. You're going to run into issues. So what? I'm getting depressed. Don't. No, Alex, you don't need to do that, dude. Look, I'm raising the red flag at the first sign of a problem because, frankly, this behavior, I'm starting to see it more and more. But there's plenty of things to be excited about in the spaceflight industry, dude. You could be excited about Starship. Like I said, you know, I don't want SpaceX being the only one with the avenue to the moon, but at the end of the day, if Elon's going to sit there and keep eating NASA's lunch and they allow it to happen, well, I don't care. At least we can get to the moon. Yeah, maybe Aqualex. Who knows? We're really back to normal. Bad space news completely derailing a KSP stream. Look, guys, it can't be happy-go-lucky all the time, dude. Sometimes you got to share bad news. You got to share bad news like this because when the good news comes around, you'll be able to recognize it. It's just like Bob Ross said, sometimes you got to have bad times so you know what the happy times are. There's going to be days where there's bad news for spaceflight. Today is one of those days. It happens. But it doesn't happen very often. It still happens. Anyway, are we ready to go back to Kerbal? What time is it? 7:12? Good. Still got plenty of time. Anyway, what I'm doing is working on Star Raker derived tech that we used from our Star Raker build to